Good evening, everybody. Welcome to Modern Day Debate. We are due for a juicy one tonight. We have Flat versus Globe, Ross Perry versus PhD Tony. And to get us started with the flat side, Ross, you have 10 minutes on the floor, and thank you so much for coming back to Modern Day Debate. We appreciate you being here.
Can everybody hear me okay?
Yeah, we can hear you.
All right, if I get too loud, please let me know. You know, I have a tendency to do that.
No worries.
Let me just a quick second to adjust myself and get my hold on one second.
I think your audio is
I can't hear.
Your audio is actually
I'm
coming through,
sorry.
it seems, through maybe your headphone all of a sudden. It was coming through your mic before, so maybe you might want to check your audio settings again in the Zoom
Okay.
chat.
How about now? Is that better?
We can hear you. That's the main thing. So yeah, you got 10 minutes on the floor, and it's all yours, Ross.
All right. All right. Well, I'm gonna. I know I said that I was gonna start the debate, but I'm actually gonna have PhD Tony start the debate. That's all right.
No, you're not. You're
screen.
going to start the debate.
I'm making a joke. Don't get sensitive on me already, Tony. I'm making a joke. All right, I'm joking on you. All right, just relax for a quick second. I got some pieces of content I wanted to show.
Yeah, I see that you're doing a screen share there, so I'll pop that up. It's just loading now. So as soon as you're ready to start your presentation, we will get started. And yes, once again, welcome everybody to Modern Day Debate. If you haven't already, hit the like button. We appreciate that. Boost it up in the algorithm and try to get this out to as many people so that we can have a big show tonight. So let's have fun. Ross, 10 minutes is started on the floor.
We've got two models, and the key question as to which model works best is to compare those models versus observations. That's the key element of science.
Okay.
If one model fails to give predictions, then it loses by default. You don't get to just win a competition by saying, sure, I can do that. You have to actually do stuff. So let's look at the most basic.
Okay, the audio is cut out again. Did you want to start making your presentation? It seems like the audio is cutting in and out a bit there, Ross. You are on
model. We've got a prediction.
Mute.
The model, well, we've got a model, we've got a prediction from that model, and we've got observations. The model and the observations match. That is validation of the model. You can't just say, well, maybe there exists.
Was the audio came through eventually? I'm assuming.
I think we got most of it, but yeah, preferably if you can start your introduction not with more commentary on things that Tony has said, but more of an evidence for the flat Earth. I understand that this is part of the debate optics, but I will re-give you your time to start.
I wanted to. No. I mean, it's fine. How much time do I have left?
So I set the clock back, so you still have 9 minutes and 30 seconds if you would like to start the presentation for the flat Earth.
Yeah, well, absolutely. I just wanted to make sure that we were all on the same page, because a lot of times when I watch these debates back, you know, people who claim to be quote unquote doctors or PhDs, they're actually pastors in disguise. They like to say that, you know, you have to have evidence for things, and if models don't work, you're supposed to throw the model out. But then when their model ends up not working, they don't throw the model out. They keep the model. And so when I'm going to show a whole bunch of evidence of the model not working. And I just wanted to make sure he's not able to say that he's not on record saying that if you have two models and one model makes correct predictions, then that model is by default the correct model. Right? So I'll go ahead and start my presentation. I didn't really want to spend too much time going over the same presentation that I always go. Like I said, I'm undefeated with this presentation, and so if you guys want to hear me, go through all the evidence and everything again, you can go watch my other debate. I'll go through it. I'll quickly outline all of the things. Excuse me, quick. Sorry, 1 second. All right, I'm going to quickly outline the things that are irrefutable at this point, and then excuse me. Okay, I can share my screen one more time. That's all right.
I think so, but it does seem like you may be coming in a little slow on the internet side.
Well,
So.
this is my presentation now, so.
Okay, no worries. Hopefully the internet clears up
slow on the internet side.
A little bit, but no
Okay,
worries.
I have a lot of stuff running on my computer, so I can close. Yeah, I'm going to close something down so that way I can come in quicker.
Okay, all right. So.
Well, yeah.
Just given the preamble, I'll just stop the timer. But we are at 8 minutes. I did start the timer, so.
No, it's fine. It's fine. I'm gonna when I start going, I'll get through it quick. You know what I mean? But I wanted to show those videos so that way, because I'm gonna be referencing those videos pretty much for the rest of the debate. I'm probably just gonna keep referencing those videos because we're gonna be going through the model. He's gonna say that they have these predictions. I'm gonna say that they don't. And then after that, we'll just keep referencing himself, debating himself. I guess at the end of the day. Sorry about that, guys. I had every time I try to prepare, I try to prepare stuff. It always messes up. Either way, all right. So, is my screen sharing now?
Yeah, your screen sharing. I started the timer, so yeah. Let's get to it.
Okay, all right. Well, like I said, everybody's already seen me do this presentation. I'm literally undefeated with this presentation. Nobody's been able to refute a single one of these points. All right. So I'm not on the flat Earth side. All right. I'm on the side of the Earth that follows the laws of physics. Okay. So if you are on the side of the Earth that defies the laws of physics, right, then you are a quote unquote science denier. All right. So tonight the debate is probably going to be between me, somebody who follows the laws of physics, right, and studies what most physicists believe about the Earth, and somebody who is a science denying preacher. I get you have the PhD attached to your name, but out here in these parts, the PhD doesn't really mean anything if you're not in the field doing research and presenting evidence for the topic that we're talking about. Because you can be a PhD in astronomy, that doesn't mean that you know how to do a surgery or anything like that. So I don't consider to be a doctor or anything like that. I consider to be, let's say a journalist, right? Somebody who studies what people in the field are doing, and then I report on it. All right. So I'm just giving you the findings of what I have. I'm just reporting the findings that I have come to from studying the subject. Number one, the Earth is not moving around the sun. All right. So this is not up for debate at this point. All right. So if you are defending the globe, you're defending a globe, right, that is not moving. All right. So we can get into the debate about how people are on the bottom of the globe when it's not moving. I'm open to hearing your evidence and your scientific experiments that prove that something like that is even possible, but I doubt we're going to get it. Number two, the Earth is the center of the cosmos. Now, mind you, this is not even a scientific point.
Right quick, Ross, I'm just going to pause your timer. I'm so sorry to interrupt you again, but it does seem like you may have the wrong mic settings selected. It sounds like it's coming through the headphone speaker. I thought it might be okay, but it seems like it's coming back through feedback. So Zoom did update, so I'm sure this is not your fault. Can you go into your mic settings and just make sure that you've selected that microphone in front of your mouth right there?
Is that better at all?
Oh yeah, much better, I think.
That's better?
Let's keep going.
Okay.
I'll start the timer again. You still have 6 minutes.
It's all right. Even with that, even though this happens every time, I'm still 7-0. All right. So either way, the Earth is the center of the cosmos. It's not a scientific point because it's not falsifiable. That's not up for debate. The surface of the Earth is not curved, or the surface that we live on is so big that the curve is virtually undetectable. So I would love to see some evidence for that. Number four, everything is energy. This is also not a scientific point, but I like to throw it in because people always want to know why. Why would they lie? Why would they this? The reason is because all of these findings are different keys that lead to us being able to understand what the world truly is and being able to harness free energy, which you can imagine is going to cost a lot of people billions and trillions of dollars. All right. So can you let me know when I have 2 minutes left? All right. I'm going to run through the evidence really quick. All right. Number one, the Earth is not moving. There have been tons of experiments that have done on this. Aries failure, right? To quote one of my favorite guys, McToon, Winston asked McToon one time, how can you prove that the Earth is not moving around the sun? He said, you attempt, right, to test motion and you get a no result. How many times has that been done since the 1800s? We've done that test probably over 1,000 times at this point. Not one test has come back conclusive that the Earth is moving, let alone moving around the sun. Not one conclusive test. So Aries failure is one. Like I said, I explained this last time. This is the original document. All right, go look it up if you're really that interested. Number two, Michelson and Morley. Right, a lot of people like to say, "Oh, well, Michelson and Morley didn't prove the Earth wasn't moving. It proved that there was no ether." All right, well, here's Einstein saying, according to the general theory of relativity, space without ether is unthinkable. Oh, and then they say, well, it's not that ether, it's a different ether. Well, it's not the space ether. All right, be quiet now. All right, you don't know what you're talking about. You're just making shit up. You're just making shit up. You're defying the laws of physics. I mean, I have this in here because Craig tried to say that the proof of the theory of relativity was the Eddington experiments, and he bet me 20K, right, that Eddington was not a fraud and did not falsify some of his data. I mean, Craig, you owe me $20,000. All right. So then you have the CMB, the cosmic microwave background is proof, or at least, like I said, it's unfalsifiable. So you know, it's the best evidence we have that the Earth is in fact in the middle of the universe. We can go through that if you want, but all other physicists agree. So if you disagree with me that the cosmic microwave background shows that the Earth is in the center of the universe, you disagree with Lawrence Krauss. But when you look at the CMB map, you also see, you can read it in your own time. All right. And then you have the Hubble tension, right? So like you said, if you have two models, one model makes a prediction and the other one fails to make a prediction, by default, the failed prediction has to be thrown out. All right. So the Earth not being the center of the universe, and the Earth being the center of the universe, right? The Ptolemaic and the Copernican system, right? That's what we're modeling against each other, all right? Mathematically and practically, they're the same thing, except for one of them has failed predictions. That would be the Copernican system, all right? So your model has failed predictions. Like I said, we can get into it if you want. One of the most surprising findings is that the fluctuation in the cosmic microwave radiation temperatures at large angular do not match those predicted by the standard Big Bang model. This is the European Space Agency. If you're not disagreeing with me, you're disagreeing with the European Space Agency. You're a science denier. You're a science denier if you disagree that all evidence shows that the Earth is the center of the universe. All right, so we can go through these quotes if you want later. Let's see, evidence two, the shape of the Earth, right? So if you have a conductive sphere, all right, a conductive sphere will give off a certain magnetic field. It will be a circular magnetic field that gets weaker as you go away. This is not what we observe on the Earth. This is right out of Richard Feynman's textbook. This is the magnetic field on the Earth, right? And this can only be basically, at least in the known laws of physics, this can only exist with perpendicular plates. All right, so the surface that we live on has to be perpendicular. I'm not saying what the shape of the Earth is, I don't know, but the surface that we live on has to be perpendicular because of the magnetic field of the Earth. This is not up for debate. I mean, look, I would love, and I already went over this last time, radio frequencies, we've set radio frequencies at a level that where they should be getting blocked by the curve, right? You can pretend like the radio frequencies do this, but when you shoot microwaves, they're basically line of sight. So if I take a mirror flash, mirrors do not curve around the ball, right? So if I flash a mirror direct line of sight to you, when you're supposed to be curved, this is proof that there's no curve right there. I'm not saying that there's no curve. There's no curve right there, okay? So look, give me some evidence that there is curve, or you're a science denier at this point. Let's see, what else do we have? Yeah, this is explaining basically what I just told you about them sending those frequencies. And I have a whole list, literally a whole list. I'm not going to share it, but there's a whole list of different times that this experiment has been done where they sent these microwaves too far
30
for there
seconds.
to be a curve in between. How much? 30 seconds?
Yeah, you have 30 seconds left.
All right, so also magnetic declination, okay? The magnetic declination chart is more proof that the Earth cannot, at least the surface that we live on, cannot be a sphere, all right? So I'm just gonna make this very brief. Like you said, if you have two models and one works, and one makes good predictions, the other one doesn't, which one works, all right? So right here, this is, let's say, essentially the Gleason map, all right? You can go read, the reason why there's a magnetic declination chart is because when sailors would try to sail using this map, the map, the Mercator map, the one we have today, they would crash
Time.
into land bodies that weren't supposed to be there. They were 200-300 miles off of where they were supposed to be. This is a fact. That's why they came up with the magnetic declination chart. You know why? Because the map really looks like this. This is what the map really looks like. We don't need magnetic declination when you use this map.
All right, we need to put a bow on the intro. Sorry, Ross.
Okay, sorry.
We are at time.
We have two models, this model and this model. I've already shown you 3 or 4 different predictions. These are not my words, all right? So if you disagree with this, you're a science denier and you're a pastor. Over to you, Pastor Tony.
All right. Well, with that,
I'd like to take issue with what was just done.
well, just 1 second there.
I have a PhD in geophysics. I have studied the shape of the Earth and its gravitational field for 30 years. And I object to the idea that I am talking outside of my expertise. And I object to the suggestion. I object to the suggestion that I am a liar and that I am scientifically incompetent. While I'm speaking, can you do me the courtesy of maybe being quiet?
We are going to.
Is this the intro, or
we're going to treat this as Tony's intro.
All right, my bad.
Go ahead, Tony. We're going to start your 10-minute, and we will do.
I'll let you object.
Hold on.
Can you?
You will have to be put on mute, and we do need to stop the screen share as well. So, I know that we're, like I say, new to the update on Zoom. It's definitely different than how it was for everybody. But let's get back to our main debate screen. So yes, let us carry into Tony's intro statement. I want to welcome everybody to Modern Day Debate. We are a neutral platform hosting debates on science, politics, and religion. We hope everybody feels welcome here at Modern Day Debate. And we are going to do a Q&A at the end of our discussion here. So we got another screen share coming up. So this is hopefully Tony's screen. I would hope so. Tony, you got 10 minutes on the floor. It is all yours.
Okay, we're going to start with actual quantitative predictions between 2 models. We have 3 axioms. If we know a location's latitude, we know the distance of that location from the North Pole. If we know the longitudes of 2 points on Earth's surface, we know the angle they subtend at the North Pole. We can accurately determine latitude and longitude for specific locations from observational data. So this leads into, if the Earth is flat, then this gives us a very simple planar triangle. We know 2 sides, we know the angle between them, we can solve for the 3rd side. As Ross has said, this is the azimuthal equidistant map projection centered on the North Pole is the only map projection with these properties. We can do the same thing on a spherical Earth. We can, if we know the latitudes and longitudes, we know the angles to the North Pole, we know the angle between them, we can solve for the distance and we can solve for the heading. This is the most basic problem, and here are the formula for these headings. This is the most basic problem in navigation. This problem is solved accurately and reliably many thousands of times every day. By aircraft traveling on intercontinental trajectories, by ships sailing across intercontinental oceans. We have the sailing manuals from the 17th century, which show us that back then they used spherical trigonometry in order to navigate. We can use the distance formula and we can compare the flat Earth distance formula and the spherical distance formula for objects that are physically measurable, like railway lines. In this case, I've chosen 2 railway lines, one between Jacksonville and Pensacola, and the other one between Tookoula and Kalgoorlie. And we can see that the spherical distance formula well matches the observed distance. We can also note that these 2 tracks of railway line are equally north and south of the equator. If the Earth were flat, then the southern hemisphere train line must be longer per unit of longitude. It must happen, but it doesn't happen. In fact, they're about the same length in terms of units per longitude. And we can verify this observationally, but Whitsitt spews some word salad, and apparently the fact that observational reality matches the spherical distance formula doesn't matter anymore. So the fact that the spherical distance formula works every single time requires that the Earth is spheroidal. And if you want to present evidence that the Earth is not spheroidal, you have to provide an example where the spherical distance formula is inaccurate. We also notice that as we move across the Earth's surface, the elevation angle to celestial objects changes by 0.000157 radians per kilometer. That is 1 over the radius. This is the definition of curvature. This is the mathematical definition of curvature. If the angular deflection of the tangent vector and the normal vector is per unit of distance traveled is the definition of curvature. Flat earthers don't know what curvature is. They've never looked at it, so they don't know. And if you want to argue that there is no curvature, show me an example of where you can move and the elevation angle to celestial objects does not change by this quantity. Similarly, we can look at observations of earthquake propagations. We can see that earthquake wavefronts propagate outwards from their epicenter in a circular fashion, and they converge inwards on the antipodal point to the epicenter in a circular fashion. We can look at the travel times. The travel times are utterly inconsistent with a flat Earth model. Flat Earth doesn't have a model for predicting this. We can look at Rayleigh waves. Rayleigh waves are a particular style of seismic wave that travel around the Earth multiple times. Here's a schematic of how they work. The epicenter is at the top. They propagate out. They get to the receiver. Then they go all the way around the Earth. They come back from the other direction. They get picked up again. They go on. They come back the second time, and then they go around on the third orbit, well, the third circuit of Earth, and they get picked up as R4 waves. This pattern of propagation is also observed in atmospheric pressure waves that result from volcanoes. They go out from the center, they go around, and they come back. So this is only possible if Earth is a spheroid. It doesn't occur if the Earth is not a spheroid. We can look, but apparently, again, the fact that the spheroidal model matches the observations doesn't matter. So let's look at how shithouse flat Earth predictions are. We can look at the sunrise and sunset for the equinoxes. For all mid-latitude locations, sunrise and sunset at the equinox occurs approximately 6 hours before noon. Sunset occurs 6 hours after noon. They occur at approximately the same time for all mid-latitude points. And for that day, the sun is close to the equator. That means that we'll also define the hour angle, which is the hour between the meridian of the observer and the meridian of the celestial object, in this case, the sun. So we know where the sun is at sunrise on the equinoxes. It's got an hour angle of 90 degrees and it's about over the equator. Okay. Flat earthers say that sunrise and sunset because of some sort of angular or distant threshold or that sort of thing. We can test this. We've got points like Hammerfest in Norway, Coldstream in South Africa, clearly not the same distance from the sun, but getting sunrise at about the same time. The distances are not the same. So one way around this is to claim, well, this map isn't actually right. Actually, Coldstream is further eastward, Hammerfest is further westward than is shown. But that doesn't work because then you run into the exact opposite problem at sunset. Sunset occurs at the same time, but they're not the same distance from sunset. Elevation angle cannot explain it either. If the distances are different, the point that's further away has the smaller elevation angle to the sun. So there's no threshold here. So explain to me how sunset and sunrise is occurring. The flat Earth distance and angle explanation simply doesn't cut it. We can add one more observation. On the day of the terrestrial equinox, the sun rises at very nearly exactly east for all points on Earth. That's not true on a flat Earth. On a flat Earth, the sun rises at 45 degrees north of east and sets at 45 degrees north of west. We can add yet more observations. The Northern Hemisphere winter solstice, the North Pole experiences 24-hour darkness. Here's a diagram of that. The North Pole is much closer than Sydney, so why is it dark all day in the North Pole while Sydney gets 14 hours of light? How does this work on a flat Earth? Flat Earth has no mechanism for explaining this, no mechanism for predicting what we're going to see at these points. So flat Earth completely fails. We can add another observation. For points in the southern hemisphere, the sun generally rises approximately east and sets approximately west.
30
that
seconds.
Isn't the case. We can look here at the spectrum of sunrises and sunsets over the year. They're mostly in the north. So the flat Earth absolutely fails. It is an abject failure at every level. And I can go through and I can explain exactly how we get the result, the formula that predict where things rise and where things set for every celestial object that is known for every day of the year, given your location. Okay, thank you.
No worries. Well, thank you so much, Tony, for your introductory statement. And there, I'll just end the screen share just as we've discovered before, the new update has been giving us a little bit of trouble. So we'll just go back to the main screen. And once again, thank you, everybody who is here in the live chat. We appreciate everybody who has already hit the like button and shared this out in those lovely spaces that they like having these discussions. I'm going to get a poll fired up for the 400 plus people that are already watching right now. So you can give us your thoughts as to where we are on our topic. So flat versus globe, we're going to hand it back over to Real Offended. So Ross, the floor is yours to respond to some of what you've heard, and feel free to inject Tony when the time feels right. Let's go into open discussion.
Very good presentation, by the way. I'm going to take your word for everything that you said. I didn't really see anything in there that I could say was, oh, that's completely wrong. I didn't see any conclusive evidence of anything as well. And on that note, I want to say that the problem with the model conversation, because like I said, I really just wanted to bring that up because like you said, if two models make a prediction and the prediction is wrong, you got to throw that model out, right? But to be real, even if a model makes proper predictions, that doesn't mean the model is correct. I hope you're at least honest enough to say that that's true, right? Because it is. No matter what shape we think that, no matter what shape we think the Earth is, right? If I make a model that works based upon all observation, I could say that that's a flat Earth model, right? And if it's on a globe and the flat Earth model works, that doesn't automatically make the Earth flat now. No. I have to do a real investigation. I have to have real experiments, real observations. If I'm going to claim something is true, I can't just have a model. A model is not necessarily evidence. And even if it is, sort of evidence, is not conclusive by any means. You disagree with that?
Yes, I do.
Okay.
Frankly, agreement between a model and observations is the only criterion for determining whether or not a model is valid. An inability of a model to match the I let you speak without interrupting you.
I'm going to try. My bad. Go ahead. You're a PhD. I have so many questions. I want to learn from you. My bad. Go ahead.
Let's carry on.
Okay. Agreement between observational data and the model is the only criteria for determining whether or not the model is valid. Once a model fails to match the observations, then we can regard it as invalid. Now, you clearly
I have another question. I got you. You know what I mean? Now, my next question to you is, are you saying that validity automatically assumes truth?
No.
Okay, so that's right. We're on the same page.
Okay, so a model can be accurate and be incomplete. It can be falsified by later data. It can be, right. So
that's why, even though I might have said it wrong, I wanted to make that clear that even though somebody can make a correct model, it's not just conclusive evidence on its own. You do need some other things in there. But if you do make a model and it's falsified through the model, then you have to take it off. So I wanted to make that clear for everybody in the audience, because sometimes it's just like a whole hour on the model, and it's like, all right, but even if you are right, it doesn't get us anywhere, All right, so my next question to you, go ahead.
Well, I would make the point that the inability of the flat Earth to answer the questions that I asked during my presentation that is a significant problem for flat Earth being taken seriously.
I would agree. I agree 100%. Okay. Now, my only thing with that, though, is just because you haven't found an answer, that doesn't mean that an answer is not out there, right? I'm not saying that even if they do find an answer, it'll make it true. But for you to say there is no answer for this period, you would have to have explored all answers, wouldn't you?
Yes, you would. So
you believe you've explored all?
Well, you asked me a question. I'd like to finish it with 2 sentences. Yes, but all of our scientific results are contingent on the data that is available to us now. So if new data comes along, we can say, okay, I said that such and such was impossible. I was wrong about that, and we have to be honest when that occurs. Okay. But
so when the CMB was released and the data showed that what we had predicted from the universe in total, which even though it's not directly the shape of the Earth, like I said, we can get into whether or not we have a spherical Earth that's not moving, but the data show that there should be recourse. Yes.
Well, can you bring up the quote from Lawrence Krauss again from your presentation? I'd like to address something in that quote.
Sure. And it's not just, I have a ton of these quotes that aren't just by him, by the way.
No, I understand. And you're making a valid point.
Or just read it.
If you could show it, that'd be better.
Sure. Yeah, no problem.
All right, let's pull up a screen share, and yeah, it looks like we've got everything worked out on our end here, guys. So once again, if you haven't already, hit the like button. We'll get the screen share up and running. We are in open discussion, and it looks like it's going to be a good one. So as soon as you're ready, Ross, with the screen share, just let me know. And it looks like that's up and running. So we can see that.
Yeah.
Let's carry on.
So the point that I would make here is that the CMB is weirdly correlated with the plane of the Earth around the sun. If you don't believe that the Earth moves around the sun, then the CMB's correlation disappears, right? And it's no longer noteworthy, right? So you're saying the plane of the Earth around the sun doesn't exist. Therefore, Krauss's quote is meaningless.
That's, you know what? I want to give you more credit than that, Pastor Tony. But see, now you're starting to slip into religious land when you start talking like that.
Because no, is that not what he said? Is that not what he said?
I'll read the quote again. All right. So, but when you look at the CMB, you also see that the structure that is observed is, in fact, in a weird way, correlated with the plane of the Earth
around the sun.
Is this Copernicus coming back to haunt us? They're saying that it could either be the Earth is moving or the sun is moving. Because
no,
it looks like
not
everything.
What they're saying. That's not what he's saying.
All right, hold on.
Krauss does not suggest that the sun could move around the Earth.
Okay, so are you saying that we have proven that the Earth is moving around the sun? Are you saying we've proven that?
I am saying that the evidence that we have available to us is entirely consistent with that hypothesis.
Okay, so now you're a science denier because all physicists disagree with you on that.
No, they don't.
Okay, so here's Stephen Hawking right here. Here's Stephen Hawking. To the question whether or not the motion of the Earth in space can be made perceptible in terrestrial experiments, we have already remarked that all attempts of this nature led to a negative result. McToon said, if you want to find out whether or not the Earth is moving, you try to test motion and you get a negative result. This is Stephen Hawking.
If only you hadn't cherry picked that quote, you would have noticed that actually we can for instance, with satellites that move away from Earth, measure the movement of the Earth, right? That's not a terrestrial observation.
You're the PhD. You tell me. How do we do it? Because I have not seen it. Stephen Hawking hasn't seen it.
No, that's not what Stephen Hawking said.
Okay, here's a different quote.
So which is no.
This is. Hold on. Come on. Listen.
No.
Be civil. Be civil. So which is real, the Ptolemaic or the Copernican system? Although it is not uncommon for people to say the Copernican system proved Ptolemy wrong, that is not true. That is not true. One can use either picture as a model of the universe. For our observation of the heavens can be explained by assuming either. So why are you a science denier now? This is why I said that. You think I'm not. Come on, you're denying.
No, I'm not. So, okay. For starters, where did he say that?
Sir, are you okay? So are you saying that we have proved that the Earth is moving around the sun?
Yes.
How? How did we prove that?
We used non-terrestrial observations.
Which non-terrestrial observations did we take? When were they taken? And how did that prove that the Earth is moving around the sun?
For instance, placing satellites in the Lagrange point of Earth's orbit around the sun and getting them to make observations of the solar system.
Lagrange satellites. And when did this happen?
There are plenty of them.
Okay, so is there any data? Because today they keep saying that we can prove it, but for some reason there is no data. You know, you can shut us all up in 1 second. You really could shut us all up right now, PhD. PhD, you have a chance. Shut us all down. Pull it up.
Okay.
Like, look, here's the data. Shut us all down right now.
All right. Okay. I'll open a window. Can you stop sharing?
Yes. All right, I'm sorry.
No worries. I can stop the share on my end. Like I said, it's all changed up. So go ahead, Tony, when you're ready with your screen share. Once again, I'll remind our live audience that all of these debates are uploaded. I can't speak. Speaking is hard. They're all uploaded to podcast form within 24 hours of us hosting them. If you want to catch the live and be able to interact with the speakers on camera and put in a super chat and see what they have to say about your thoughts, you're going to want to subscribe to the YouTube channel Modern Day Debate. So check us out on YouTube. And Tony, your screen share is ready, so whenever you're ready, let's continue.
Okay. We can bring up the data from the Parker Solar Probe, for instance. A probe that was sent to the sun. We can bring up the telemetry mission for the so let's just do that. That Parker Solar Probe telemetry data. Okay, so you can download the it says here you can download the level 0 telemetry data from the Parker Solar Probe.
And what is that data going to show us?
That data is going to show us the position and the distance of the solar probe as a function of time.
Okay, and how does that determine motion?
How does that determine motion?
Yes, so we're talking about proving that the Earth is moving. This is a huge deal right now.
Yes.
Listen, when I go outside, I don't feel any motion. Nobody has any proof of this. All right, they've tried for years. You're trying to tell me that it's a done deal. How have they proved that the whole Earth is moving? It's defying the laws of physics. You're saying that the Earth defies the laws of physics. It moves 1,000 miles in a spin, and we don't feel it. And then it moves however many thousands of miles, and we don't feel that. That defies the laws of physics, sir. So if you want me to believe that, you're going to have to show some evidence.
Okay, actually, you're wrong. It doesn't defy the laws of physics.
Which part was I wrong about?
Okay, can you shut up while I'm speaking?
I'm going to try, but...
Okay, the part that you're wrong about is defying the laws of physics. The laws of physics do not change if you are moving at a relatively constant velocity. The laws of physics so if you're traveling at 1,000,000 miles an hour, it doesn't change the laws of physics. Throwing something up will still result in
Okay, so does the Earth ever slow down or speed up?
Yes, it does.
So how come we don't feel it? You just game up. I won. He just said if it's a constant speed, you don't feel it, but it slows down and speed up. Let's move on to the next one. All right?
No, let's not move on.
Let's move on.
Let's not move on for the next one. Let's not move on for the next one.
Easy layup.
Okay, you asserting that what you said is right is not the intellectually honest argument.
You said was right.
Can you shut up?
1 second there, Ross. So I'm just gonna place you on the mute. 1 second there, Ross. We're gonna let Tony go through his explanation, and if you want a minute, I'll give you a full minute to respond. You just have to ask. So go ahead there, Tony.
Okay, the accelerations that the sun undergoes through the course of a year, the changes in angular velocity, the day length varies by about 5 seconds either side of average throughout the year as a result of Earth's elliptical orbit around the sun. Those accelerations, so there are about 3.15 by 10 to the 7 seconds in a year, and we're going through 2 pi. So Earth's angular velocity is 2 pi divided by 3.15 by 10 to the 7. So that's about 10 to the minus 7 meters per second squared. That's the magnitude of the force. It's r omega squared. So it's tiny. It's a really, really imperceptible amount. So no, you're not going to feel that. Your vestibular system is not that sensitive.
That's ridiculous. All right, because you're saying, like, look, just for everybody in the crowd, like I said, when I use the word science denial and define the laws of physics, I'm not joking. All right, he's saying that you can move 1,000 miles per hour, but you don't feel it because you don't change speed. Then I ask him a direct question. Oh, but does the Earth change speed? Well, yeah, but it's so small. Look, see, define the laws of physics, sir. You're not going to fool me, all right? That's why that PhD don't stand for doctor. It stands for a pastor. Pastor
okay.
Tony.
So my question to you is, why are you in this debate and not a physicist? Why, if you claim, let me finish my question. If you claim that what I'm saying violates the laws of physics,
yes,
why do physicists agree with me and not with you?
Which physicists?
Every one of them.
Well, I pulled up some actual quotes from some actual physicists. Do you have quotes from actual physicists disagreeing with anything I've said today?
Yes.
I will pull it up. Pull up a physicist that say, oh no, there's tons of experiments that we've done that show the Earth is moving. Pull up a physicist that say, no, the CMB, it don't look like the Earth is in the center. It looks like the Earth is moving. Pull up a physicist that will stand on that ledge. I pulled up physicists, quotes from physicists. I pulled up experiments that back up what I said, and I pulled up papers. I pulled up papers from Cornell University. He disagrees with Cornell. Is this what they do over there in Australia? You guys don't respect. You guys don't respect universities and accredited papers. And that's what I look at. Right. Based upon the accredited papers, hey.
We're gonna give.
They agree with me.
Let's give Tony now a chance to respond to what you're saying there. He's getting some searches up here. So I'll just remind our audience again that we are going to take questions at the end. So if anything that you're hearing right now is sparking a thought in your mind and you're saying, oh my, I'd really like to get the speaker's thoughts on that, or I'd like to grill this person on XYZ, put it in a super chat and they'll be asked with priority. So Tony, I'm going to cede the floor over to you to talk about what you have in front of us right now.
Okay, so here's a physics quote saying, as I said, that the laws of physics remain invariant under a Galilean transform, which is to say under a transform with uniform velocity. Now, if the acceleration is small, then this approximation, 2.3.1, remains valid. That's what it means for acceleration to be small. Because the velocity does not change very quickly. So this is, and you can read any physics textbook.
Can that be demonstrated?
No, I'm still talking. I'm still talking, right?
Are you not aware that you do this in every debate you have?
My lips are moving and words are coming out.
You know you do this in everybody else, right?
All right. We're going to have to. All right. Once again, Ross. If you would like, you can ask me for some time to respond. Even if you're like, hey, can I inject here? That's totally cool. We can, like I say, we can disrupt the flow. But if you just cut in, it does make it difficult and throws people off. So just we're going to let Tony wrap up. This is throwing him off more. So go ahead, Tony.
Okay, so small accelerations do not disrupt this. They do introduce artificial forces, but the magnitudes of those artificial forces are dependent on the magnitude of the acceleration. So if I can demonstrate that the acceleration is small, I can treat this as a Galilean system. And every physics textbook in existence will explain to you that this is the case. And if you don't accept that this is physics, then you don't know what you're talking about, and you're lying when you say you do.
All right. It is. I'm fast to take you off the mute there, Ross. So I'm going to go back to the main screen. Go ahead.
Yeah. See, the reason why I cut in sometimes when he starts talking at length, because he's very slick. When he understands that I have an easy rebuttal to something that he says, he'll say it and then move on to another point to try to distract the audience from the fact that what he said was incorrect. All right. So, like, it's not just that those 2 or 3 physicists that I already read. Every physicist in the world, I don't know. Look, here's a quote from Julian B. Barber, a physicist. Thus, even now, 3.5 centuries after Galileo, it is still remarkably difficult to say categorically whether the Earth moves. All right. So you're acting like I'm saying this stuff. None of the words I've said today have come out of my own mouth. You're disagreeing with physicists. You're the science denier, not me. You're the religious person, not me. I'm on the side of science. All right. I'm on the side of science. Here's another one. We can feel. We can't
Actually,
feel our
I'd
motion
like to
through
interject
space.
there.
We can. All right, but okay. But wait, I'm done. We can't feel our motion through space, nor has any physical experiment ever proved that the Earth is actually in motion. I can go through hundreds of quotes from different physicists, mathematicians, astronomers, all agreeing with me. So you brought up something that said that, well, excuse me, what you brought up was not a physicist disagreeing with me. You were trying to make your point again about not feeling the velocity. And so that's why I shifted to, can you demonstrate this in the lab? Because I want you to show me where in a lab somebody can go 1,000 miles per hour and then the velocity changes a hair and it's not feelable. You can't just say that. Remember your quote at the beginning? You can't just say I can do this and then you win competitions. That was you saying that. Did you forget already? No, you said you can't just say you can do stuff. You have to actually do stuff. So is there an experiment that proves what you're saying right now? You can go 1,000 miles per hour in a circle and not feel it, and then also add 5 different motions? Because you're saying that you won't feel it if you have one motion. How many motions does the Earth have? The Earth has like 5 different motions. Go ahead. The Earth has 5 different motions. Explain all 5, because you can't even explain one.
He's just gish galloping.
Which part did I say that was incorrect?
Unacceptable.
Don't talk about what I said. Tell me what I said was it. Teach me, PhD Tony. Treat me like a student in your class. What did I say was incorrect? Help me gain knowledge.
Okay. I'll treat you like a student in my class. Shut up and stop interrupting.
Is this why you guys talk like that in Australia? All the teachers just tell you guys shut up.
Well, when we're lecturing in front of a class,
shut up, Tony.
All right, just 1 second, Ross. Before we get into meta.
I got triggered. My bad. That's my fault. I got triggered. Shut. I said, teach me.
No.
Up.
You're gonna go back on mute, and we're gonna let Tony bring up the next point. I'm so sorry, Ross, but if you keep trying to engage in this way, it's just not gonna work out for a productive conversation. So we do really want to unpack. We don't want to just jab at each other. So go ahead, Tony. You were trying to move into some new territory or response. So go ahead.
I was trying to address the misrepresentation of those quotes. When he says that it's difficult to demonstrate that that the Earth is in motion, there is a possibility that the laws of physics as we understand them are completely wrong, and that there are many other forces at work that are moving stuff at faster than the speed of light around us. It's difficult to argue against that position, but it is equally not the case that they are saying we have proven the Earth is stationary. That is not a correct interpretation of what they're saying. They're not saying the Earth is stationary. They're saying that it is, we have constructed a model for the motions of objects inside the solar system and throughout the portion of the universe that we can observe that makes sense, in which we are moving around the sun. And I will step further into this. The claim that we are at the center of the universe is transparently false, because the distribution of stars around us is not what it would be if we were in the center of the universe. We're not even in the center of the galaxy, right? So how can we be in the center of the universe? To be in the center of the universe, the mass of the universe would have to be distributed uniformly around us, and it isn't. So this entire line of reasoning is fatuous. He's cherry picking these quotes, and these are actually not quotes from scientific papers. And I want to make that point very clear. These are not peer-reviewed comments. These are private comments in popular science media that he has taken out of context in order to make the claim that the Earth is stationary. The available evidence to us suggests that that is inconsistent with the laws of physics as we understand them. And his claim that physicists agree with him is not true. And if it were, then all of these physicists that he's citing would be flat Earth debaters, and they would be here instead of him.
Fantastic. For all the people in the comments saying I'm not listening, I am listening. I'm taking notes too, all right? Okay, so that last thing that you said was you're either severely misinformed on the subject or you're dishonest. I don't want to put that on you because I saw how mad you got. So let me not ruin the debate because you are emotionally out of control. But based upon the distribution of stars, the Earth actually looks exactly in the center. So that's what the C and B, that's why the C and B keeps getting redone and redone. They keep claiming it's instrumental error. So that's just not true.
Correction. Right? I want to make a correction.
I let you go. See, this is why I did this to you first.
He's just wrong.
This is why I did this to you first.
He's factually incorrect. He's factually incorrect.
But tell me after. Tell me when I'm done.
What's the point of letting you prattle on when you're starting?
All right, so don't be mad when I interrupt you. All right, so don't be mad when I interrupt you then, okay? It's fair game, right? Turnabout is fair game. Okay. So based upon the distribution of stars, the Earth is exactly in the center. That's 100% true, all right? And I do agree with what he said, that just because we cannot conclusively say it's moving, that is not conclusive evidence that it's stationary. We both agree on that. But based on all evidence so far, the Earth is not moving, all right? All physicists agree with that. He keeps saying I'm cherry picking quotes, but he hasn't pulled up one quote of a physicist disagreeing with that. Not one, all right? And then he said, there's a possibility, or no, this was first. He said, the laws of physics, he said, it's a possibility the laws of physics could be completely wrong. See, that's him trying to find a way to slick justify, because he knows that deep in the reasoning of what the globe is, it defies the laws of physics. So they have to accept that at some point. Matter of fact, dark matter defies the laws of physics. It's been debunked already. So gravity relies on dark matter. Dark matter defies the laws of physics. It's been debunked. The gravity, the way we know it, has been debunked. That's why they don't call it mass attracting mass anymore. Anybody who's on the leading edge of science would know this, or you're just disarmed, all right? And then, you know what, I'll leave it there, because that's pretty much everything that you said. Yeah, the distribution of stars and the C and B, right? That's why they call it the axis of evil. They call it the axis of evil because, wow, it looks like it all leads to a central point. If you draw a straight line here and a straight line here, in the center of that is the Earth. It matches the prediction of the Earth being in the middle, the Ptolemaic model, not Copernicus. Okay, it matches Ptolemaic, not Copernicus. PhD Tony said in the beginning of this debate that if we make a prediction that don't fit, we have to throw it out. Copernicus is out the door. All right, Copernicus is gone. All right, and I get it that mainstream science hasn't caught up yet, but the people who are on the leading edge have known this for a long time. All right, so don't be upset just because you have to unlearn and relearn something. That's the sign of intelligence. All right, just because you thought you knew something and now you don't know anymore, humble yourself. All right, I had to do that. Hey, I don't know, and that's why when PhD Tony tells me I'm wrong, I say, PhD, don't tell me I'm wrong. Show me, pull it up, teach us all, teach the class right now. Let's go.
All right, we're gonna hand the ball over to Tony.
Okay, for starters, the claim that stars are distributed as though the Earth is at the center of the galaxy is just a simple falsehood. The distribution of the Milky Way across the night sky is clearly not symmetrical about Earth. So that claim was just false. The claim that the CMB is aligned on Earth is not true. As Krauss himself suggested, it's aligned with the plane of Earth's orbit around the sun. That was Krauss's statement, and that's the axis of evil. So you can't use the CMB to argue that the Earth doesn't go around the sun. That is implicit in the definition of the axis of evil. As for not being on the frontier, when was the last time you published a paper on Earth's gravitational field? I'm going to guess never. I've published several this year. So saying that I don't know what I'm talking about when it comes to gravity. And also I will make two other points. One, Earth's motion is not related to its shape. This is a cube. That doesn't change just because it's rotating. It doesn't change just because it's moving. Similarly, the cosmic microwave background doesn't affect the shape of Earth, doesn't relate to the shape of Earth. These are irrelevancies. And he's just getting away from the fact that distance formula don't work, that the propagation of seismic waves doesn't work, that navigation doesn't work, and that the prediction of the motion of planets and stars and sunrise and sunset and the rise and set of every celestial object simply doesn't work on a flat Earth. So how about, instead of distracting people with stuff that is completely unrelated to shape, you start talking about the evidence you have for the shape of the Earth?
All right, so all that sounds good, and I'll take your word for it, Pastor. But you didn't show us any evidence of that. You just asserted it, And so that's textbook sophistry. He hasn't this. He hasn't. Listen, I started off with experiments, point blank period. These are experiments that are repeatable. You can do these. These prove the shape of the Earth. Now, so you said the Milky Way across the night sky. Okay, so the reason why I brought up the CMB, it wasn't proof that the Earth is not moving around the sun. CMB was evidence toward the Earth being in the center of the universe. And when Lawrence Krauss says that it matches, it correlates with the plane of the Earth around the sun, this is why I question the PhD thing, right? Because when he says that, right, he's saying that we think the Earth moves around the sun like this, right? And he's saying that the CMB matches that motion, what we think the Earth is doing around the sun. This is not about whether the Earth is moving. It's about it being in the center of the universe. So what that means is the same path that the Earth has around the sun, it matches the whole galaxy. I hope you understand what he's saying. He's like, that doesn't make any sense because it's supposed to be random. But for some reason, the whole galaxy follows the path that we think the Earth is taking around the sun. So you're telling me that the Earth is taking that? No. More realistically, that whole galaxy is moving in that path, and it even has the tilt that we claim the Earth has. That's what he's saying right there. He's not saying that it has to do with the Earth moving around the sun. So if the Earth's not moving around the sun, the CMB is null. I'm not sure how you pulled that, how you even got that out of that. I just wanted to make that clear for the audience, right? That is not what that means. He's saying what we think the Earth is doing, it looks like the whole universe is doing that in plain language. What we think the Earth is doing, it looks like the whole universe is doing that. So it's more realistic that the Earth is not moving because based upon the laws of physics, that's what we observe. All right.
All right, we need to hand the ball.
I have several corrections.
Go ahead. You can deal with that one first because you said a bunch of stuff. Go ahead.
First of all, the CMB has nothing to do with the galaxy, right? The galaxy and the CMB are different things. The distribution of the stars in the galaxy is unrelated to the cosmic microwave background. They are different things. They don't relate to one another. So saying that the CMB is aligned with the plane of Earth around the sun is not the same as saying the galaxy is aligned with the plane of the Earth around the sun. You seem not to understand that distinction.
I said it was in plain language. I'm not saying a one-to-one for the people in the crowd who aren't going to spend thousands.
So for the people in the crowd who don't understand science, you're going to say it wrong. How about you say it right? The galaxy has nothing to do with the
Tony?
CMB.
Hey,
the
Tony.
galaxy is not aligned with the plane of the Earth around the sun.
Is this upsetting you, Tony?
Yes, you're a fuckwit. And fuckwits annoy me. So
I'm a bucket. I'm a bucket? What does that mean?
Fuckwit.
All right.
I'm a fat.
No. All right.
All right.
All right. Not that you're not taking it in great stride, but yeah. Let's try to push into some new territory. Not just like I say, semantics or meta discussion on who could know what, but like evidences. So let's get into it.
All right. So again, with the cosmic microwave background, right? Yeah, like I said, it's not about whether.
Talk about the Earth. We're talking about the shape of the Earth.
Ryan, I'm trying hard not to joke, all right? But for your sake, I'm trying hard not to joke. But he's throwing me alley-oops. I want to joke on him so bad. I'm going to stall you out, though, Tony, because I can see you're already mad. All right, so the Rubik's Cube example, right? And matter of fact, perfect segue. The reason why all this matters, like I said in the beginning, because once you get rid of the fact that we don't have evidence for all this other stuff, now you have to explain a spherical Earth that's not moving in the center of the universe. So now you have to explain to me how, if we're on a sphere, how are we on top and somebody on the bottom and it's not moving? Where does the gravity come from? That's confusing. So that's my first question. And then my next question, since you want to talk about the Earth so bad, how do we have, well, first of all, you're not disagreeing, right, that we have a linear uniform gradient in the magnetic field, right? You agree with that at least.
It's linear with radius, yeah, but it's radially, but it extends radially. It does not extend.
What do you mean by that? Extends radially.
So the equipotential surfaces are approximately parallel to the surface of the reference ellipsoid.
I understand that you did a good job painting that picture for me, right? But now my only thing is that there's no place on the Earth where it's radial. It's always linear.
No, it's radial everywhere.
So not according to Richard Feynman. So you're just reading the science again.
I'm sorry. Did Richard Feynman say that the Earth is flat? No, he didn't.
We're talking about
the clearly he doesn't agree.
This is an all or nothing fallacy. Calm down. It's all or
no,
nothing.
It isn't.
Fallacy, right?
No, it isn't.
You know what an all or nothing fallacy is?
Yes, I do.
Okay, what is it?
An all or nothing fallacy is the claim that you have to agree with everything that somebody says in order to use data that they're saying. But
so you just said Richard Feynman didn't say the Earth was flat. He doesn't have to agree with me for me to use his data. Thank you for clearing that up for us, Tony. Thank you for clearing that up.
Except that peer review is based on the following. If you look at the data and you come to a different conclusion from the author, you say logically, I use the same data, but I come to a completely different conclusion. Peer review says you're wrong. That's the purpose of peer review. The peer review process is to determine what logically follows from the evidence that was presented.
I don't know how we got the peer review, but I want to know about the linear distribution that we have. That's
it's
impossible
not
on the sphere.
Linear.
So you're a science denier again. He disagrees with Richard Feynman.
No.
Right.
So Feynman also, if we want to get into this, actually I have a presentation. May I share my screen?
Oh, God.
Yeah, you sure can share your screen. And I'll just remind our audience, we are just over an hour of since we started our debate here. Generally, we will go into Q&A, within probably 10 to 20 minutes, but it just depends on our speakers and how long they want to go. So if you have questions for either of our speakers, get them into Super Chats now, and they will be read with priority. So your screen's up and running there, Tony, so the floor is yours.
Okay. So we start with an observation. All unsupported objects near Earth's surface experience a downward acceleration of approximately 9.8 meters per second squared. This downward acceleration is applied regardless of the object's mass and composition. Note for flat earthers, the word helium balloons and that sort of thing are supported by the atmosphere. Remove the atmosphere, they become unsupported. We have another observation. There is an electropotential current near Earth's surface of 100 volts per meter, and that is with the Earth's surface maintaining a negative charge, and that we now hypothesize this is what causes downward acceleration. Okay,
Yes.
this is a testable hypothesis. We can
Yes.
introduce two plates with an opposite charge, a separation of 2 meters, potential difference of 200 volts. We charge them up. Now, in between the volts, there is now no potential gradient. So if we introduce an object into that green area, it should float. It should not move downwards because there's no electropotential gradient. We can repeat the same experiment, except we can increase the potential difference. If we introduce an object in between there, it should shoot upwards at 9.8 meters per second. That is not observed to happen. We can come up with another observation. Actually, things in contact with the ground have the same charge as the ground. That's what the term grounded means. So if this potential difference was what was causing us to move down, we would not have weight because there's no potential difference between us and the ground. Zero potential difference, zero force. Therefore, there should not be a weight. We can do another experiment. We can show that actually the voltage that you need to lift an object is more like 1,000,000 volts per meter in order to lift 0.1 milligrams. This is a scientific paper. I've given the reference here since you're so keen on them. So the fact that you need a larger voltage to lift something than you do to force it down tells you that there is something other than and much larger than the electric field that is forcing things down. Whitsitt has done an experiment that has debunked his own claims, and he's too dumb to work it out. Nor is any other flat earther bothered to tell him of the stupidity of what he has overlooked.
Stupidity. All right. Well, I agree with almost everything that you said there, except for you didn't quite answer how that's even possible with a spherical surface. You need two conductive plates, and just so the audience knows, right? Just so the audience knows, right? I don't know. I have to dive deep into his explanation on what experiment should prove that you can manipulate the field to change the weight. But the experiment that he brought up that Whitsitt did is not Whitsitt's experiment. This is an experiment that engineers have been showing at least as long as I've been alive. All right, my uncle was the first one to show me this experiment. You can basically get a Van Graph generator and flip the field. You can flip the polarity of the field, and then the object will float. All right, and also you can introduce sound, which I had a huge back and forth with McToon on why sound is also electric frequency. So you can manipulate the electric frequency with sound, or even during rainstorms, right? During lightning storms. Lightning will manipulate the frequency, and then it will affect the weight of things. All right. So, but this is not a debate about that. We're talking about the shape of the Earth now. So how can you? Since we both agree that is the gradient. Can you demonstrate in an experiment? Has it been demonstrated in an experiment that gradient is possible on a spherical surface? Show me where that has been demonstrated in a lab.
Okay. Well, it's been observed in nature. We know that the charge at the top of the atmosphere is different from the charge. And when you say that it's a vertical gradient, when you say that it's that's just an approximation that Feynman was using. Feynman would have agreed, like every other person who maps Earth's electromagnetic field, and there are people who do this professionally, that it is actually radial, it is not vertical.
Okay, so let me ask you a question.
So it extends radial.
Specific on that. So wouldn't a radial distribution get weaker as you go away?
Yes.
Why does our distribution get stronger? See, two predictions.
Doesn't.
Radio, you just said it has 100 volts.
It doesn't.
Goes up.
It doesn't.
So what does it mean when you say that 100 volts as you go up, meaning the charge gets stronger? What does that mean then if you're saying it doesn't get stronger? If there's more electricity as you go up.
If you would shut up long enough to let an answer sneak into this conversation, you might learn something. The near Earth surface, the gradient is 100 volts per meter. As you go up by a meter, the potential increases by 100 volts. but that does not continue. As you go up, that you need to go further in order to get your 100 volt increase. So it tapers exactly as you suggested. It does not, the gradient gets weaker as you move upwards. It does not get stronger.
I mean, you can say that, but demonstratively, observationally, like I said, if it was radio, it would get weaker. We observe it getting stronger. Now you're saying, yeah, but it's only in our observable area when it gets stronger. Once we get to the area that we can't necessarily go ourselves, trust me, it gets weaker. Believe in me. I promise. No, I swear. I swear to God. Do I have experiments that prove it? No, but I swear to God. You swear to God. I got you.
Okay, so what you want is radiosonde data of electromagnetic field strength. Bring it up. Go and search for you screen share. You do the search. Radiosonde data of electromagnetic field strength.
So you're not quite sure just yet. Is that where we are? You're not quite sure.
Well, I don't see how you can be sure if you haven't even done the Google
I'm
search.
not saying I'm sure. I'm saying
well, yes, you are. You're saying that I'm wrong.
Well, I'm saying that you don't have evidence for what you're saying. That's all I'm saying. I'm not even saying you're wrong. Hold on, look, just to be clear, I'm not saying you're wrong, all right? Because you could be right. You really could. But it's not just about you being
How
wrong
about
or
you
right.
do? How about you do the Google search?
I did the
of
Google search.
radiosonde data of electromagnetic field strength.
If you haven't done it already, that's fine. I'm just saying, you have to have evidence for what you're saying, whether you're wrong or right. I don't know if you're wrong or right.
Well, you presented the claim, you dickhead. Like you presented the claim. You presented the claim. I'm still speaking. You presented the claim. You presented the claim that this was impossible on a sphere. You made that statement.
Yes, I said a sphere.
And now you're claiming that you could be wrong.
Okay, of course.
You don't know that you're right.
I'm a real scientist.
Why did you make the claim?
All right, look, let me be clear, all right? I said, and you agreed, that a spherical object would have a radial distribution in the magnetic field. We both agreed with that. So that's not necessarily my claim. That's a claim in science, all right? We all agree on that. And then what we're disagreeing on is whether or not our distribution is is linear, and whether or not it increases like linear distributions do, or it decreases like radial distributions do, based upon Richard Feynman, and you agree too. Your diagram shows that in the measurable universe that we inhabit, it increases linearly. It increases.
No,
you agreed on that. So
no, I don't. It's so. Look, a plot for 3 meters near the Earth's surface cannot be meaningfully extrapolated to the rest of the universe. And for you to even make the suggestion that that is true is completely fucking bonkers.
So to be clear, you're saying that all the other evidence I have is true, but it's just not a wide enough area for you to say for sure. All right, and I'll accept that.
No, I'm saying that you completely misunderstand the topic on a fundamental level.
In which way? Which thing did I say that was incorrect? Correct me, please. I'd hate to be. Go ahead.
You said that the gradient that you presented is impossible on a sphere, and it's not. You can have that value in the lower atmosphere and have a different gradient as you move upwards.
You got me. All right. You know what? You get me on that. The score is 75-1. All right. You're right. I misspoke. Okay.
Yeah. You know how in all sports, one of the competitors gets to choose whether or not they win. That's exactly how competitions work. You get to decide whether you won every point.
Okay. So.
Maybe it would be a good idea just to put a bow on some of the things that we've gone into. If there's any hot ones that we haven't been able to get into yet.
I do have something to bring up.
Sure thing.
Okay.
Okay, I just want to put a bow on that, though. Just to put a bow on it, all right?
No, we're not.
Come on, chill, all right? Because I was in the middle of speaking, all right? And I was giving you a point. I was saying you were right about something, so I want to give you that. I made a mistake by saying it's impossible on the sphere, but we just have not demonstrated it. I would like to see demonstrations that a distribution like that could exist on a sphere anywhere. Based upon the known laws of physics, that's a bow on it. Let's move on to the new point. Pastor Tony.
Let's not. Let's look at, so you're looking at the Feynman lectures, right?
Yes.
Okay, if you go to figure 9.4 in that Feynman lecture, you can see that at 50,000 meters above sea level, the potential difference between that and the surface is only 40,000 volts. It's not 5 million volts. Right? So this is observational data that the 100 volts per meter does not extend indefinitely above Earth's surface. Would you agree?
Yes, 100%.
Okay, so would you step back from your claim that Earth's electromagnetic field is impossible on a radial Earth?
I already did. I stepped back and it's impossible as a stretch, but it has not been demonstrated though. It has not been demonstrated.
Except that we've done it here. We've measured it here. This is a measurement of Earth.
The shape of the Earth is what's in question, though. You don't get that, Tony? So you can't use the Earth as evidence for the thing that's in question. You have to do something else. Find a lab.
Do you understand how idiotic what you just said was? You can't use the Earth. You can't use the Earth to demonstrate the shape of the Earth. That's effectively what you just said.
No, that's not what I said. I said to demonstrate this principle on whether or not this is possible, you have to use something other than the thing that's in question. You don't get that? That's like saying, that's like saying, hey, the Bible says that Jesus is real. And you're like, well, how do you know? I'm like, because it says right here on page 22. I'm like, no. The Bible is what's in question. You can't use the Bible. No. That's how ridiculous what you just said sounded. Pastor Tony, I'm like, listen, man, the PhDs is Jesus.
Okay, so can you tell me Coulomb's law?
Let's pretend I don't know. How does that relate to what we're talking about?
Because it gives you the distribution of electrostatic potential in a spheroidal, around a spheroidal body with a charge distribution.
Does it match the Earth?
Yes.
I would love for you to pull that up. I would love that.
I just did.
No, because that, no, okay.
Okay, so we've got
No, you put up my data. That was my info that you put up. You said this is what you're looking at, right? Yeah. You have to pull up somewhere where, okay, this is what it would look like on a sphere, demonstrated here, and here. And this is what it looks like on the Earth. That has not been done yet. All right.
Okay, well, let's go to my field of expertise then, shall we?
Sure.
Let's go to gravity.
Oof. Let's do it.
Okay, so you apparently don't accept that mass attracts mass. In fact, you say people have stopped saying that.
It's not the bending and warping of space-time now, right?
Yes, it is.
Oh, so it's not mass attracting mass. I was correct again.
It is that too.
Oh, it's both. Oh.
Yes.
And you're positive about that?
Yep.
Okay.
So it depends a little bit on your framework. You can have philosophical discussions about which is what. But let's look at some papers on gravity. So let's assume again that your Whitsitt's electrostatic theory of gravity.
Witsit, sir, just so you know. Like, you're not debating Witsit, you're debating.
Are you denying so what's your proposed mechanism for gravity? You had the dielectric thing up there before.
Right. Yeah, but this doesn't have anything to do with Witsit, though. Attack the idea. Attack what I'm saying, because he pulled that from other scientists. He did not come up with any of that.
No, he didn't.
That, right? You know that. He didn't come up with any of that.
Okay.
He's reading and researching like a good scholar should.
No, he isn't. He's making shit up.
Yes, he is, because he's finding the same things that other of us are finding. He's just finding the same things that we're finding in our readings.
So here we have measurement of gravitational acceleration by dropping atoms. Atoms are electrically neutral. They do not have charge distributions. So the mechanism is you've got a trap. You project the cesium atoms up, and you look at their properties on the return. This field has been extended to what's called cold atom interferometry, cold atom gravimetry, it's called. Here, for instance, we've got a setup with a magneto-optical trap where we project strontium atoms into an observation chamber. We hit them with a laser. We select out we apply our clock perturbation. We select out atoms that have not made it into our velocity requirements. We then hit them with a Raman laser that will project half of them upwards. Then we recombine, we pass them through, then we recombine and we look at the matter wave interference. And from that, we can measure gravity. Again, we've got evidence that atoms fall under gravity. Here we've got neutrons falling under gravity. Here you project neutrons into a cavity between a mirror. You use ultra cold neutrons so that they remain trapped. They end up in bound gravitationally captured quantum states, and you can measure them using height distributed sensors like this, and you can compare your results to the calculated values like this. So the green is the properly computed. The red are the observed intensities of neutron flow as a function of height above the mirror. So neutrons fall under the influence of gravity. Neutrons have no charge. An electrostatic field has no impact on neutrons. We can demonstrate this in the laboratory. So the claim that the electrostatic field is responsible for neutrons falling is instantly falsifiable. It has to be something other than electrostatics.
I'm just going to assume that everything that you said in that was correct. But even if it is correct, though, it still doesn't lead to the conclusion you want. It's a total non sequitur, right? I said this in the Craig debate, right, where you guys will say like 10 true things in a row, like this is true, this is true, this is true. I'm like, I'm with you, I'm with you. And you're like, and so that means that it has to be gravity. I don't. Is it dishonesty or is it ignorance? I'm not sure. Because in a proper scientific experiment, you have to be able to manipulate the variable that you're claiming is the cause for for the outcome, right? Like if I say the light is being moved by the volume knob, I have to be able to manipulate the knob. So you guys have to be able to affect what you call quote unquote gravity, and you have to be able to affect the quote unquote electrostatic field, manipulate it so that way you can be sure that these are not the things that are the cause of your outcome. You haven't done that in any experiment, definitely not the one you just showed.
Yes, we have. That's just a
so
lie.
How did you differentiate between electrostatics and quote unquote gravitational pull? What did you do to differentiate between those two?
Okay, so
just to be clear, a lot of that also it assumes that you understand the nature of how electricity and these neutrons and atoms work in general. Because we haven't even really identified the electron like that to even know that it exists. When you look at the Higgs boson and a lot of the other colliders, they're starting to realize that there's a lot deeper, there's basically a deeper coding, quote unquote, level to these things. And these things are more of an interface rather than the deeper coding of what's really going on. So we don't actually understand the nature of how these particles move anyways. Now, this is a leading edge of science. I know, so you might not even be aware of this. But if you are reading what's coming out of the colliders, yeah, a lot of these things are being completely debunked, namely the existence of the electron in general.
So I'm going to show this, and then you're going to bring up a scientific paper concluding that the electron doesn't exist.
Well, I would hope you bring up an experiment that everybody can do. Because the papers
no,
don't mean anything.
you're
That's
going
why
to
you're
bring
a
up.
preacher.
No, you're going
to
bring up a scientific paper that demonstrates.
I'm not a pastor. I don't want people to worship paper. All right.
So,
paper.
So that in this case we've used our attractive masses in two ways to look at in the left hand side. This is a time of swing experiment. So you bring the masses in the middle there. There's a pendulum which is suspended from a silicon fiber. Our test masses, those black things on the outside, stainless steel balls suspended on tungsten. We vacuum out the thing with the lever in it. We cover it by a gold-coated cylinder to shield the system from electrostatic effects, and we place everything inside a vacuum to remove out air. So the mass here is an aluminium coated silica block. So it's just made of purified sand with aluminium on top of it, and the outside is stainless steel. So we've reduced the magnetic effects. Then we've got a second experiment which actually uses a different.
I heard your answer. I heard your answer.
Okay. So your claim, no. I hadn't finished speaking. Your claim that we hadn't excluded electromagnetic forces is wrong, isn't it?
It's not. I'm going to explain to you how. Because you're saying that you blocked it. You cannot block electrostatic effects.
Yes, you can.
So there's not there's not static electricity and interference in a vacuum?
Yes, there is, but
okay, so you can't block out electrostatic effects even in a vacuum.
No, yes, you can. You can put part of the apparatus inside a Faraday cage, and you can make the Faraday cage solid so that the frequency of the electrostatic forces that can get through it is small.
Small, yes, but not there though. The electrostatic
but you can reduce it to.
I agree.
You can reduce the influence of electrostatics to much smaller than the effect of gravity. So you can eliminate electrostatics. You can eliminate electrostatics as a potential causal mechanism.
Walter Lewin from MIT, go look up his lectures. I've been over this at infinitum already. All right, Walter Lewin at MIT disagrees with you. So this is not me versus him. This is Tony, Pastor Tony versus science. He's a science denier. At MIT, Walter Lewin.
Why isn't he here?
Walter Lewin.
What does he say? Bring up the paper in which he says it.
I brought up a lecture in my other debates.
Bring it up here. You're not in your other debates.
I'm not doing that right now. All right, go look up the Walter Lewin lecture.
Then it doesn't exist. I'm not up against Walter Lewin. I'm up against
MIT
you.
doesn't exist.
I'm up against you saying somebody said something. Somebody said something. That's evidence, isn't it?
Listen, man. Listen. All right, so look, just like I said in the beginning, all right, we're going to keep referring to your original quote, all right? If you have two models and the model makes a prediction and the prediction fails, you throw it out, all right? The prediction for gravity was thrown out in 1933. That's how far behind science Pastor Tony is. In 1933, there's what's called the Fritz-Wiki observations. He looked out into the galaxy and he thought, hey, based upon what we think gravity does, there should be this much mass. There was so much less mass than what was predicted. They had to come up with dark matter, all right? Why was dark matter invented? Dark matter that we can't see, can't touch, can't interact with, matter that's not there. Defying the laws of physics, right? Well, how did we come up with that? Because we made a prediction based on gravity. It came up false. This was 1933, guys. 1933, gravity's been debunked. Why are we so arguing about this? This is done already. Cook turkey.
So there are 2 points to make. One is that a theory that is valid on Earth is not disproved by what happens in a galaxy far away. 2, in order to accept Zwicky's result as valid, which clearly you do, you have to accept the existence of galaxies.
They made dark matter. So everybody
you have to accept. So on the record, Ross here accepts the existence of galaxies outside of the Milky Way. He accepts that Earth is located inside a galaxy, and he accepts the heliocentric. If he doesn't accept those, if he doesn't accept any of those, then he doesn't accept Zwicky's result as real. And if he doesn't accept Zwicky's result as real, he doesn't get to cite it.
He forgot what an all or nothing fallacy is that quick. He said, see, this is why pastor, right? Because you'll say one thing and then you'll live completely different.
You reject everything about Zwicky's analysis. It's not a matter. If you reject all of the
that.
observational data that Zwicky is introducing, you can't adopt his conclusion because now he has no data on which to base the conclusion. You reject all of his observational data. You can't just say, I take the conclusion and then I apply it. In order to take his conclusion, you must accept his data and his methods. If you don't accept that, you don't get to use the conclusions.
We heard you. All right, and I hear you. But that's ridiculous because it's called an all or nothing fallacy. And what I would be doing is invoking a hostile witness. That's called a hostile witness. I can't believe they don't teach you logic in Australia. It's just like
I've actually done formal logic. Wits that tried this nonsense as well. It's not. I've done formal logic. I passed formal logic.
You said what an all or nothing fallacy was. You said that.
I do, and it's not an all or nothing fallacy. You are rejecting everything about Zwicky's paper except for the conclusion. You can't do that. It's not logically valid. It's not logically valid. It's not logically valid. And you saying that it's an all or nothing fallacy is just you asserting that you win again. Again, you're not the judge here.
Winston, what have you done to this man? This man has nightmares. He's thinking that he's debating you right now. He's waking up in the middle of the night sweating, thinking about that debate with Winston, don't you?
No.
I didn't listen. These are not Winston's words. I learned this my first year of school because I went to school for political science. Logic 101, all or nothing fallacy. Just because you say 100
this is not an all or nothing fallacy. You're just repeating yourself. This is not an all or nothing fallacy.
Hello, excuse me. Hello, relax, Jug. Relax, Jug.
All right, we're gonna have to move into Q&A if we can't actually, like I said, we can't just be. You know what you're doing is not cool, so let's carry on.
Funny, anyway, just because I disagree with 10 things that somebody says, if they say 2 + 2 is 2. I don't have to now think that 2 + 2 is 4. I don't have to now think that 2 + 2 isn't 4 just because this guy just says some stuff I disagree with. I don't know where Tony's mind is at today. I really don't know. Come on, man, get it together.
So just saying that something is an all or nothing fallacy, or just saying that something is a fallacy, is not an establishment that fallacy validly holds in the context that you're using it. So just saying that's an all or nothing fallacy, that's an appeal to authority fallacy, that's blah blah blah. All physicists think this when they demonstrably don't. If all physicists thought that, if all physicists thought what you think, then you wouldn't be here. You'd be replaced by a physicist who would be telling me how I'm wrong.
That's not even an argument. That's not even an argument. What argument is that? If you're so right, then a physicist would be here magically. Magically, a physicist would just take your place. Make an argument about what shape the Earth is. Make an argument that the Earth is moving. Make an argument that the Earth is not in the center of the universe. You know what I mean? And show some evidence. Because you're saying that I'm wrong, but you don't show the evidence contrary. No evidence contrary.
I did. I showed.
You showed papers, not experiments.
No, I showed. The papers describe experiments, you cretin. Also, I showed that the spherical distance formula is always accurate. You can't show that it isn't. I showed that I showed observations of spherical models of seismic arrival times. They're always accurate. You have no model. You didn't show that they weren't. I showed that spherical models of Earth's electrostatic field were accurate. I showed all of this observational data, and you've just fucking ignored it.
No, I didn't ignore it, but we agreed in the beginning that models are not evidence alone. So
models of validation, observational validation is intrinsic to whether or not a model is right.
But we agreed that that's not conclusive evidence for truth. We're searching for truth.
Yes, but you haven't presented a model for these phenomena. We need to be able to compare how these
You're right, Tony. You're right. Okay, you're right. But the reason why I haven't presented a model is because models aren't conclusive evidence. I've presented evidence, not models. Experiments.
No, you didn't
evidence,
present evidence.
Quotes and papers.
No.
I provided all of them.
So this is the fallacy. This is the fallacy.
What is it?
Flat earthers think that they can read a scientific paper. It's not the case that anybody can read a scientific paper and properly understand it. I can't read a quantum mechanics paper and
Okay, but
properly
that's why I have
understand
the
it.
quotes from the physicists
So
that agree.
yes, you've taken quotes from people out of context. You haven't given.
If they're out of context, show me them in context and show it how it contradicts.
You have not cited where these quotes are from, whether or not they're peer-reviewed, whether or not they're peer-reviewed comments, whether or not they're just off-the-cuff comments, whether or not they're informal dialogues, whether or not they're just from popular science books.
I'll give you that. I'll give you that. But
you haven't done any of that.
I agree. But this is what I'll say, though. This is what I'll say. If anybody cares about the subject for real, if they care about truth, go look up what I'm saying after. And if I'm wrong, come correct me, right? But think about it like this. Let's say what I'm saying is true. What if what I'm saying is true, right? If all the stuff that I'm saying, you can say that it's wrong, go look it up for yourself and find out if it's true. And when you discover that it is true, then what? Now what?
Okay.
Now what? Now what? If I'm correct, then I'm right. If I'm correct, then I'm right. Then the Earth is not moving. Okay, so like deal with that then, because there's no evidence to the contrary. Don't tell me that what I'm saying is wrong. Show me contrary evidence, please.
Once again, he interrupted me when I was making my point. The person to ask about the proper meaning of a scientific paper or an utterance by a scientist is the scientists themselves. So if scientists agree with Ross that the Earth is flat and that the evidence supports it, then they will say so. They do not say so because they do not agree with this. Ross has read stuff. He thinks he understands it. He thinks he understands the mindset. And you will notice very often he goes into magic. He can mind read what Lawrence Krauss meant when he said that he gave the thought process of Lawrence Krauss's utterance about what Lawrence Krauss was referring to. No, you can't do that. You don't know that. The best way to get at this is to ask Lawrence Krauss, are you saying the cosmic microwave background demonstrates that Earth is at the center of the universe?
So if I bring up a video of
Krauss will answer, and again,
right?
He's interrupting me, and Lawrence Krauss will answer, no, that is not what I'm saying.
Okay. So if I bring up a video of Lawrence Krauss saying it, you'll say, you know what, Ross? I was completely wrong. I'm a dumb Australian. Sorry. You'll say, Ross, I was completely wrong. You were right. You didn't take it out of context. You'll say that if I bring up a video of him saying it.
No, I will say you're right.
No, you're right. No. Right.
I will say you're right. You asked me a question. Are you going to let me answer it?
Sure.
No. What I want is I don't dispute the accuracy of the quote. What I dispute is your interpretation of it. So the key discriminator, I'm still answering. The key discriminator on whether or not your interpretation is correct is to go back to Lawrence Krauss and say, did you mean to say that the Earth is at the center of the observable universe? And Lawrence Krauss will say no. He will say Ross's interpretation of what I said is wrong. So it doesn't matter how many quotes Ross has, because the people who said those things do not agree with his interpretation of them.
Okay, so for the record, everybody can go look this up on their own. There's tons of videos out there of Lawrence Krauss talking about this at length, actually. That's how I know that. Right? I didn't pull that out of my ass. I've heard Lawrence Krauss talk at length. He's actually my favorite physicist to listen to. I watch his show almost every week. So shout out Lawrence, right? One of my favorite guys to listen to. I disagree with a lot of stuff Lawrence says, but I think that he's a brilliant man. And he looks at things from a logical perspective, and he's very good at communicating it, all right? So you can go look this up on your own and see that PhD Tony is misinformed. Excuse me, Pastor Tony. All right, he's misinformed on that subject specifically, so.
Again, I am not disputing the accuracy of the quote. I am disputing your interpretation of it.
He's explaining himself.
And I am still speaking. And it is your interpretation of the quote that is at issue here. You are saying this quote is evidence that that all physicists think that Earth is at the center of the universe. And your interpretation of the quote is wrong, and the physicists maintain no such thing. So while the quote is accurate, what you are claiming to be the consequences of that quote, the logical entailment of that quote, is simply false. You have made shit up based on a quote that you have misinterpreted.
All right, sounds good. Well, let's see if I misinterpret this quote. So this is a quote from Nikola Tesla. Today's scientists have substituted mathematics for experiments, and they wander off through equation after equation and eventually build a structure which has no relation to reality, right? We all love data sets, and data sets, yes, do count as evidence, but not conclusive evidence alone. Data sets, mathematics, papers, none of that is conclusive evidence. Conclusive evidence is experiment, and then that experiment has to be repeated, and that experiment has to come after observation. All right. So this is why I say he's a science denier, and he believes in stuff that defies the laws of physics. Because in reality, we don't observe any of the things that he's saying. We observe the world the way it is, and then they come up with all these different weird ways that it's really not that, it's an illusion. That's really what they're saying, right? Do we see the earth moving? No, we can't. And when we do an experiment, is the earth moving? No. But guess what? It's an illusion. That's the answer. All right. Gravity is real, but it doesn't map on to reality, right? It doesn't map on to the whole solar system. It doesn't map on to all the galaxies, right? But there's dark matter there, right? You think it's not there, but it is there. It's an illusion. You understand what I'm saying? That's the side. They're trying to convince you to believe in illusions. All right. Don't let them do it. Just because they have the word PhD in front of their name, it does not mean what you think it means, right? It means pastor. It means pastor, preacher, Tony.
All right, guys. I think it might be a good idea for me to chime in with my very feminine voice and push us into the Q&A. As somebody has put in the
I have one quick
so
point
much.
to
I'm
make.
sorry.
Can I make one quick point?
You want to put a bow on something? I'll give you like 15, 30 seconds here.
Okay. So the sorry, let me find my window.
I have a feeling that this is not going to be a 30-second bow, is it, PhD?
It should be reasonable.
Reasonable? Okay, well, we'll see what your thoughts are on reasonable. Go ahead there, Tony.
Okay, so here's a plot of the night sky. Okay, this is how we map things in the night sky. You will note that there's a thing called the celestial equator that is 90 degrees away from the pole. That makes no sense on a flat Earth. The equator is not a plane. In observation, the celestial equator is a plane. In a flat Earth, that can't be true. It's a cylinder, and the angular separation of an object from the equator, that angle is going to depend on a flat Earth, on where the observer is. So the claim that the flat Earth observations, the claim the flat Earth observations match reality, completely false.
Right. Well, see, but that doesn't take into account the azimuthal field of vision. All right. That's very, very easy answer to that. Everybody, please go look that up on your own. Azimuthal field of vision. That's why the angles are off. Euclidean geometry does not work at long distances.
All right. So what we'll do?
Asserted without basis.
Okay. So what we're gonna do is we're gonna move
I'm sorry. Just for the record, you're saying that we use Euclidean geometry at long distances?
Yes.
So how do railroads touch in the distance then, if it's Euclidean?
We'll carry on.
Exactly. It makes no sense. Let's carry on.
That's perspective.
It makes no sense.
That's perspective. They don't touch.
Yes,
they never
so
do. They just appear to.
Thank you. So you're talking about the perspective of where we see stars. Perspective is altered by the azimuthal field of vision. There's no Euclidean geometry. You're trying to calculate it like it's Euclidean, and perspective will change. Ding, ding, ding.
Yeah. You're
ding,
asserting that without evidence. You're just asserting
that.
There's
tons of evidence on this. You just brought up last second.
Then present it. Then present it.
You brought up last second.
Present the evidence. You just
I'll do it on my after show.
Present
I'll present the evidence on my after show. How about that? Pull up on my show after. I'll present it to you, Tony.
No, present it now.
No, I'm not doing that now. Ryan is trying to end the show. Why are you so rude?
All right. If we,
it's all very well for him. This happened last time, Ryan. This happened last time. We got into question and answer, and then Whitsett was all about azimuthal field of vision, and he had not demonstrated it. He had no evidence for it. He hadn't even properly fucking described it, and all of a sudden it was evidence for the flatness of Earth. They do this constantly. They just introduce stuff at the last second without having established any factual basis for introducing it.
I responded to you. You introduced that at the last second.
All right. Be that as it may.
Does this work with everybody else? else, you
I
just lie
understand
and
that.
tell them that. What
I
the fuck?
understand that the expectation is that you guys aren't going to agree with each other, not only on the topic but on the tactics as well. So let's move into the Q&A and see if we can spur some new ideas and go into some new territories. So I do want to thank everybody who has come out to the show. So we just have shy of 500 people watching right now. I'm going to close the poll and I'll let everybody know where it stands. So once again, everybody's hanging out. We are going to move into our Q&A shortly. Let's
A
see
lot of
here.
bread.
I'm just going to close the poll. And that'll give you guys an opportunity to, if you need to use the washroom, you need to grab a refreshment, that's fine. I also want to remind everybody that we got lots of debates coming up on Modern Day Debate, so make sure that you check out our upcoming events and hit the notification bell. We would love to see you guys there. And let's see. Unless one of the other mods closed the poll and I didn't notice. If one of the other mods closed the poll, if they want to let me know where it stood, I'm pretty sure we were sitting comfortably somewhere around like 67% on Globe, and I think it was, there it is. It's 63% Globe, 20% flat, and then 17% voted a loaf of bread. So PhD is back. 17% voted a loaf of bread. Thank you for that. That's funny.
And no, by the way, that 17% goes to me because I said we don't know. So I get the 17% too. So,
17% too, because that's a technical I don't know. All right, let's carry into
And
our
you
super
still
chats.
lose.
No. I mean, this was a landslide.
You still got 63%.
98 to 2.
He's not wrong.
I think you had 2 good points. 2 8. I'll give you that though. Most people, they don't even get 1.
All right.
You got me on those 2 points.
All right. For the sake of our audience, let's get into the super chats. So if you have a question, get it into the super chats because we're going to get into it right now. And I'm sure that we're going to have all kinds of thoughts as we go through. LJ asks, why doesn't Earth spin under a hovering helicopter?
Well, the helicopter is suspended by the air, and the air in general rotates with the Earth as a result of 4 billion years of friction. So the momentum of the air is the same as the momentum of the helicopter. The helicopter doesn't move relative to the air. Both stay in the same relative position to the surface of the Earth. It's very simple. And here I think it is revealing that this individual thinks that this question has eluded the greatest scientific minds of the past 100 years. No, we do understand why that happens. That you don't is more a you problem than it is anything.
I think he wants to know, how do they pick up the extra speed? Because if the environment is moving at the same speed as because you're saying that it's in lockstep. So if it's further, the circle it has to take is longer. Where does the extra force come in for the environment to pick up the extra speed it would need to keep up with the Earth?
Well, it depends how high you go, but no, if you're any net lack of movement is going to. So let's suppose that you're right. Let's suppose that the air isn't moving as fast as the Earth. That's going to show as a westward wind, and the helicopter is going to have to adjust for that.
Only if it's moving. So, but real quick though.
No.
But we do agree. Hold on, but we do agree though that if the air up here 1,000 miles up is moving in lockstep with the Earth, because the circle is bigger, it has to be going faster. Yes.
But it isn't at 1,000 miles above the Earth.
Well, I mean, even if it's 10 miles above the Earth, it still has to be going faster, right?
It's not in lockstep with the Earth at 10 kilometers. So that
at anywhere where it's lockstep, if it's any amount above the Earth, it has to be.
Yes, it's going to show up as a wind pattern if it isn't.
Okay.
So the fact that winds exist is well understood, and the fact that the dominant winds are from the west is also well understood. So
that's how they made the globe model, though. That's why there really isn't a globe model. It's all a flat Earth model. They looked at what we had, and then they basically designed the globe around those wind patterns. They assumed, we have to be moving this way because of the. So it's not conclusive evidence on its own. It's evidence, but not conclusive on its own.
Yeah, but you don't have a model that explains anything. You can't explain distances. You can't explain the rising and setting of celestial objects. You can't explain where to find. You can't explain. Pardon?
That doesn't make any sense. You can't
Okay,
explain
calculate the distance for me between Sydney and
You just have
Santiago.
to go. Like, what do you mean? You just go there. You calculate the distance by traveling. Listen, if I know the distance between Fresno and LA, that doesn't mean that I know the shape of the entire Earth. We have no idea what the terrain is between LA. Hold on, listen, we don't know what the terrain is between LA and Fresno. So there could be an arc in between LA and Fresno. There really could. So there's a whole bunch of variables that you're not taking into account. Knowing the distance between one place and another does not give you the shape.
Last word to Tony for this one.
But we can prove that the flat Earth formula is not accurate. Ever. There's only one. You yourself brought up the azimuthal equidistant projection. Under that projection, the flat Earth formula is, well, not never accurate, but it's mostly inaccurate. It's by a large portion.
All right. Let's move into our next super chat. Once again, thank you to our audience for hanging out and having the discussion, and also the people in our live chat. Lots of fun going on in there. Don't think I haven't been reading and also enjoying as well. So Otto says, a question for my personal statistics. Does Flat Earth side support Ukraine or Russia? I bet it is Russia, right? Well, honestly, this is such a separate discussion. This is a strange thing to ask at this point. So here's what I would ask, Ross, if you want to personally let our audience know where you may stand on certain issues, and that might also spur some people to contact me and say, I would love to debate Ross on XYZ. So you can go ahead and answer that, or just say, I don't want to respond.
Yeah, well, I'll say that I think all wars are wrong. Period. I don't agree with any war. I agree with the non-violence principle, 100%. You should not aggress on people that are not being violent against you or not threatening violence to you or your property. Period. Now, that being said, the geopolitical complexities of the area are what we see if you dive deep into it. All right. The number one and almost only problem in the world today is the existence of government, period, and the American government is the number one culprit, all right? It's always the American government's fault. I'm not saying that because I'm an America hater. I'm an America first person. I don't want our military and our soldiers providing money or resources to wars anywhere, period. And I'll debate anybody on that.
Well, that position, if I may offer a comment, that position was adopted by the US many times ahead of World War I. It was adopted ahead of World War II, and it never worked because it always ended up that America's trading partners and the people that America was politically allied with would end up in serious trouble and would need to be helped out. So it's never worked in the past. It's not going to work in the future. In particular on the Ukraine-Russia war, Ukraine are fighting a defensive war. They didn't choose this war. They didn't start this war. They are defending themselves against a hostile, aggressive force. And murderous and genocidal that has been stealing children from Ukraine and shipping them inland into Russia. So, Putin is a murderous thug, and if he isn't stopped here with Western help, then he'll keep on going into Poland. He'll keep on going into Eastern Europe. It's not going to. You don't stop thugs like Putin by appeasement. World War II demonstrated that. And if Ross disagrees, he just doesn't know history as well as not knowing physics.
Please, this is my area of expertise, actually. I'll give you one thing. Putin is a murderous thug, so is every president of every nation ever, right? Everything that he said other than that is 100% false. 100%. 100%. You would get embarrassed in a debate about that. You're completely wrong about that.
All right.
Especially when you talk about the non-intervention policy. The U.S. non-intervention policy didn't work. The world has been to shit ever since the U.S. started intervening.
All right.
The U.S. didn't intervene. There was no World War. The
All
things we
right,
did
Ross. We
to
do
shit ever since then. All
have
right,
to move into our
that's the.
next super chat,
Sorry,
Ross.
sorry.
So,
We can debate on that later because that's crazy. You would say something like that.
we do have, yeah, I was gonna say we have quite a few super chats to go through, but if anybody has any other questions, do let us know by putting it in the old super chat there. But yeah, let's carry in and see if we can get some more back and forth here. LJ asks, the globe religion requires early childhood brainwashing with globe toys and stories. At what size do all observable flat bodies of water start to curve?
Generally around 200 kilometers. Now you can actually confirm this by putting GPS receivers on ships, and you can measure their height above the reference geoid as they travel along. So you can definitely track that. We've also got satellite altimetry images of Earth, and so if you go along the coast of India, east coast or west coast, it doesn't really matter. You'll find that the sea level is inclined, that the sea level south of India is about 50 meters lower than it is at the top of India. Part of that is to do with the mass of the Himalayas gravitationally attracting the water towards it. Part of it is due to a gravitational low where there's subducting material just to the south of India. This is called the Indian Ocean gravitational low, and it shows up in sea level maps. So whatever you're talking, I don't know what this guy's talking about. We know that water curves. We've been mapping it and using it for ages. And in fact, actually, I'll do you one better. If you've seen a map of the Earth where they show the ocean floor, that ocean floor geometry has been determined by using the gravitational signal of ocean floor mountains on sea surface height. So we look at the sea, we measure sea surface height. We say, okay, it's piled up over here. That means that there's a mountain range underneath it. And where there's a valley, where there's a depression, that means that there's some sort of chasm or something. So whenever you see those, and if you look on Google Earth, you'll see these little snail trails going across the ocean floor. That's actually the high resolution acoustic measurements of ocean floor depth that broadly agree with the gravitational. The gravitational has a lower resolution. So yeah, water curves, get used to it.
If I could just make a quick comment, because the idea
Yeah, sure.
is that we don't observe, based upon the known laws of physics, water always lays flat, right? Like think about if you're trying to make something level, there's some water in there. You know why? Because the water will always go flat. We use that to test levelity, right? Okay, so he asked him, where do we observe this happening anywhere? And because this is the shape of the earth in question. The only evidence that water ever curves is the thing that's in question. So there's no scientific evidence for this. This defies the laws of physics, what he said.
Okay. If you take a water droplet and just drop it, if you put it into 0G, it'll go round. B, if you look at water in a beaker, you'll see that there's a meniscus on top of it. So the claim that it's flat is false. And B and C, water does not
tons
go
of water?
What I'm still
70 million
speaking.
tons?
I'm still speaking. Water does not go flat. Water follows equipotential surfaces. So it follows surfaces where there is an equal equipotential, where there is an equal rotational and combined rotational and gravitational potential, and that can easily be demonstrated in lakes. So your claim is just nonsense. And
Right.
I'll say that was my question. I get the last word.
That is true. And yes, let's carry on into the next question. That is a good idea. As I see more super chats are coming in, the more you guys discuss, I think the more our audience is going to want to engage with both of you, as it has been interesting. And you guys have brought up all kinds of and I think different things than what we've heard on modern day debate in the past. So if you are enjoying the discussion, hit the like button, share this out in those lovely contentious spaces where you like having these discussions. Next question coming in from Even Lord. Did Jesus look Mediterranean or was he black?
Jesus Christ. Are they doing this because they know that I like the political stuff? All right, I don't like the political stuff, but are they doing it because I'm always discussing history? Like, this is crazy. That's funny that you said you wanted to have a debate on history, Tony. That's my specialty, actually. I specialize in history,
Yeah,
100%.
it's actually something I have postgraduate qualifications in as well. So well done you.
Amen. We don't know
In
what color Jesus was. We don't even know if he was a real person. How about that?
Yeah,
Right.
so I think most scholars accept that Jesus was a real person, and he would most likely have had a Mediterranean cast, or a Levantine, more accurately a Levantine appearance. So an occupant of the Levant.
We talking about Yeshua, or we talking about Jesus? Because Jesus is really just another name phonetically of saying the name Zeus, if we're being honest. Jesus is
I
just
don't
Zeus.
the
Hey Zeus.
transliteration
Hey Zeus. Hey Zeus.
the transliteration that I've always said is that it's a transliteration of Heshua or Joshua. I'm
Well, yeah,
surprised
that's
by
the original name. Yeah. So, but then they changed it to Jesus. So I don't know about Jesus, but Yeshua was obviously a real person.
there are people who would take issue with that claim, who claim mythologism. I personally find that not convincing as a hypothesis. I think that he did exist, and and as you say, his name would have been a Hebrew one. It
I
would
agree
have.
with that.
Let's carry on. The question is not overtly relevant to our discussion today, but once again, it could cause people to message me and say, "Hey, I really disagree with Tony or Ross on this subject, and I'd like to debate
Yeah,
them." So,
honestly, I would love somebody to debate on that Ukraine thing. Like, that's crazy. I never even considered doing a debate on that because I can't imagine how somebody could look at the facts and think. But look, if somebody wants to debate on that Ukraine thing, please, easiest debate I've had all week.
all right, Chase Hatchett says, "If I'm driving 70 miles per hour, I don't feel the difference when I slow down to 69 or speed up to 71. It's called relativity."
That's not
That
called relativity at all. But you would feel the difference when you speed up and slow down. Maybe you don't because your brain is only halfway there while you're driving. But hey, if you're paying attention, you can tell the difference between 70 and 69. Now, how about 1,000 degrees? We're talking about thousands of degrees. And we're talking about multiple motions. 1,000 degrees in a circle, that's just one motion. How fast is the earth moving around the sun? How fast are they corkscrewing? All right, all these different motions happening at once. It defies the laws of physics to think that we could have all those motions going on and not feel a single one of them.
No, that's absolutely not true. You can have as many motions, you can have as many vectors as you want of motion. You sum them all together, they only turn into one vector. There's only one vector of motion that is relevant. You sum vector, so velocity is a vector quantity. If you have different components of velocity, you just sum those vectors together, you end up with a particular vector with a particular direction and a particular magnitude. So he's obviously intimidated by big numbers, and he's also intimidated by the concept of vector sums. But vector sums are very trivial, and so I don't know why the 5 different motions keeps on getting mentioned by flat earthers. It's utterly irrelevant.
Yeah, it's quite relevant actually. Yeah, it's impossible. It defies the laws of physics that you would be moving 1,000 miles per hour and not feel it at all. Especially if you're changing speeds, especially if you're curving and moving in different motions. All right,
All
listen,
right,
demonstrate
we're
it
gonna
in a
move
lab,
on to our
or
next
it defies the
question.
laws of physics.
Uh, yeah, the question was for you, Ross, so I'll let you have that last word. Matters now. This is also for you, Ross, so I'll give you the
Is
first
that
word.
Ozian? Shout out Ozian.
That is Ozian. Well, potentially, it could be MXXD. It could also be. I'm not sure at this point. It also could be Isa. So let's just read the question and see what you think. Ross, what is the independent variables and constant for the electrostatic force? Coulomb's law, Fe equals Ke Q1 Q1 slash R two, r to the power two, is it? After show on Matters Now. I don't know.
Well,
Ozium's trying to make fun of
like
my
that.
lack of math skills.
Yeah, the
It's
question was kind of weird. What are the
so the
independent and control variables for the force? You would have to bring up a specific experiment, or you're saying how would you do an experiment and what would the variables be? I don't know. Maybe reform that question a little bit more coherent. But there's tons of control variables. That's the main point that everybody's missing. All right. There's honestly like a bunch of control variables that you can't really anticipate. You know, the day, the time of day, the weather. There's tons of things that you have to basically control for when you're doing a proper scientific experiment, and then it has to be repeated. So we can move on for that one.
yes, all of the experiments that I listed today were controlled and were repeated. What he's trying to say that what Ozian is saying, or Matters now is saying, that Coulomb's law takes the form of a constant times the product of the charges divided by r squared. So it dissipates as a function of r squared, just like gravitational acceleration dissipates as r squared. That's all he's saying.
I'll let you have the last word, even though it was for me. Go ahead.
You got it. So I think that would be the last word. So let's carry into the next question. Thank you so much. So yeah, there's going to be an after show on Matters Now. So tune in for that if you want to hear some more commentary. There might be some familiar faces over there. Melissa Schultz says, if we were turning around in one day and going around the sun in 1 year, it would gradually become dark at noon every 6 months. Ross, explain it if you can. Then Tony, answer please. So they're inviting the back and forth, but we were going to do that anyway. Spoiler alert,
Yeah,
Melissa.
I don't really quite understand what she's saying. It's not exactly my area of expertise, but I will say that again, everything that happens the way we see it on the earth is the way we see it. Okay, it means nothing for the discussion of whether or not something is true or not when we're discussing models, because the models are taking all observable information and then figuring out what we believe off that. So we all have the same information. All right, we all see the sun and the moon and the stars do the same thing. We're trying to discuss why it's happening. All right. So I can't necessarily just, like I said, it's not my area of expertise, but you to come up with an explanation on why something is happening in a model, you basically have to run an experiment on that. And when you're talking about astronomy, like this is not science at that level because it's non-falsifiable. You'd have to go up there to the stars, to all these other places to do these experiments and control for a bunch of variables. Because you can't do that, it's not falsifiable. That means it's not science. I hope you guys understand that. If it's not falsifiable, it's not science. So these are really philosophical conversations. So she's asking philosophical questions, and I invite those, but it's irrelevant at the end of the day to the scientific question on what do we know for sure.
All
Go
right.
ahead.
Your thoughts over there, Tony?
Okay, what she's saying is, if this is the sun, Earth, Earth at the initial position has this side facing the sun. What she's saying is that 6 months later, we're around the other side of the sun, and the other side of Earth is facing towards the sun. What she's kind of overlooking is that a day is not the time that it takes the Earth to complete one rotation. That's a so that would be a sidereal day, which is not the same as a solar day. A solar day is the time it takes to turn around to face back to the sun. So it's the time between one noon and the next noon. And it's off by about 4 minutes a day. So when the Earth is over here, that's enough that we're out by 12 hours. And so now sort of we're facing towards the sun again. So it's daylight. So I think that's what she's referring to. So yeah, you need to accommodate the difference between the sidereal day and the solar day, because the sidereal day is actually a more accurate assessment of Earth's rotational velocity.
All right. Any last words there, Ross, before we move into the next super chat? All right, awesome. Well, if anybody else has any other questions, make sure you get them in the old super chat. We're going to go right into the next one here. I see that there's a few more that did pop in. So once again, a big thank you to Melissa, Matters Now, Chase Hatchett, Even Lord, LJ, Otto, and yeah, let's get that next question here. Milk John's mom says Stuttering John versus Shuli. Who wins? Not sure what Milk John's
Oh,
mom
stuttering John is
means.
definitely me. I have a video on my page right now, actually, about how much I stutter. You feel me? Because a lot of people have been perpetrating the name of my people this week. People try to act like having a stutter is a quote unquote mental disability, and that's why they can't do stuff. Get out of here, all right? I study worse than everybody else, and nobody. I'm the worst at interrupting. So I don't want to hear nobody who stutters complain about other people interrupting them. All right, I am proof. You can still be an asshole with a stutter. That's it.
All right. Well, membership chat from Ozian Talk says azimuth grid of vision is subjective, not objective.
Is he saying that it's not true, or he's saying that different people have different azimuthal field of visions because their eyesight is different, or their whatever it may be. I'm not quite sure what he means, but I suppose it would have to be subjective because we're talking about perspective. And as I said, Euclidean geometry does not work at long distances. So your interpretation of how far things are is subjective. Yes, that's true.
All right. Ozian Talks also says, I am only here to support PhD Tony and for my show. Well, Ozian, thank you. It seems like you gave us $2 to support this show, so
Yeah, I guess OG
I
doesn't like
don't know
modern
what
day
you
debates
mean
no
by
more,
this.
right?
I,
I don't like modern day debates no more. It's PhD Tony or nothing.
I mean,
All right,
I'm
Ozian
just having
gang.
fun. Ozian, I do love hosting you, buddy. So, anytime, like, you send me Facebook messages, and I'll try to get a hold of these speakers that you're interested in debating. Yeah, I did find that funny as I was going through uh, the super chats that you're only here to support PhD Tony. Yes, your ruthless plug.
Hey Ozian, Ozian, I would love to. I don't know if we've had an official debate on FE, but I mean, maybe you can come redeem PhD Tony and redeem FTFE. Man, it's like not what I say 8-0 before this, 9-0 now. Like Jesus, man, like you guys need some help, man. I need some help.
Okay.
Yeah, the opinions of delusional people don't generally concern me.
All right. Positively Diverse Podcast asks, flat answer to the star's rotation per the hemisphere.
Yeah, as I said earlier, there is no globe model. They made the globe model by looking at the ways the stars rotate and assuming that it was the Earth rotating and not what we observe, which is the stars. Like, think about it. We observe the stars moving. Our answer is not, oh, the stars are moving, right? That would be too logical. We have to say, no, it's an illusion and it's fake and dark matter. And then this is, yeah, ridiculous. All right. So the stars are moving. Guess what? Because the stars are moving. I don't have to explain that. We all see that. That's what's going on. All right. I support the Earth that follows the laws of physics. All right.
I'd like to comment. The question you were asked that somebody paid good money to ask you was, how do you explain the fact that northern hemisphere star rotation paths are in the opposite sense to southern hemisphere stellar rotation paths? Why do they go clockwise in one hemisphere and anti-clockwise in the other?
Okay, well, just so everybody knows, right, just based upon the laws of perspective, if I'm looking up at a fan, right, and the fan is going this way, when I turn around, it'll be going the other way. If I'm looking the other
No,
way,
it
it'll
won't.
be.
No, that's not true.
Okay.
If you look up at a fan and it's going one way and then you go above it, it'll look like it's going in the opposite sense. But if you look at a fan and it's going clockwise, it doesn't matter where you stand under the fan, it'll still be going clockwise. That's just a fundamental property of the direction clockwise. That's why we use clockwise.
I'm not sure what we're looking at visually there, Ross, but
It's Ross pretending that he did a proper analysis and then shaking his head. That's what
I'm trying to listen. I'm trying to understand what he's saying. You know what I mean? Like I said, the laws of perspective change when you look at things from a different perspective, right? If I'm looking this way, the fan is moving like that, then that's the way it's moving. If I'm looking this way, the fan is moving like that. It looks like it's moving the other way now.
So
right?
is your
Move it
so
this
is
way.
your
Oh,
claim
now
that
move it this way.
everybody in the southern hemisphere is facing south all the time, and
No,
everybody in the
my
northern
answer, no,
hemisphere
my answer
is
to it,
facing north all the time? Is that your
my
claim?
answer to it was my answer to it. Like I said, I'm like, the stars is not my area of expertise. And so I defer to people that know what they're talking about. But again, right, all these things are laid in by the laws of perspective. And if we're talking about models, this model is a flat earth perspective in general. We look up, the stars do what they do. So now we're trying to figure out why the stars do what they do. Nobody has an
No,
answer. We don't have an
that's
answer.
not that. That's a model has to be able to predict and explain the observed characteristics of the system. If it doesn't do that, if you can't predict what the stars are doing, then you don't have a model. Science is all about determining whether or not a given model is accurate. Your inability to predict stuff, your inability to quantitatively assess the stellar motion is actually a loss. If you can't do that,
Yeah, for the
you just don't
globe.
have a
For the
model,
globe.
and you failed.
1933. You guys are
And
big
you
guns.
failed.
Last word for
Failed
Ross.
to explain stellar motion.
Last words for Ross for this one.
Listen, like I said, it's not my area of expertise. I don't get into the stars that much, and I'm not an astronomer. I like to focus on what we can confirm, all right? That's not science up there, all right? It's not falsifiable. We can't confirm it. So that's look, you want to talk philosophy on that? Cool. I want to focus on the science and what the science shows us. What can we confirm, all right?
All right. Next one coming in. This is from Kane Skeptic. All right. So this says, this is from Kane Skeptic. Sorry, I had to turn up the mic a little bit there. Ross, you can't listen if your mouth is moving. Oh, they're getting spicy on you there, Ross. If you ask a question, be courteous enough to listen to the answer. Well,
Listen,
that's a little bit of meta discussion, so maybe best we just don't interact too much with that one. But that is your first super chat, so we'll give you some.
Listen, I love modern day debates, right? I really do. I watch modern day debates all the time, right? All week, I'm watching one debate or another. When I watch PhD Tony, he is annoying. He does not be quiet. He does not let other people talk. And this is the same thing that I did to Mark, right? When I watch debates, and it's the reason why I wanted to debate Mark. I watch the debate. Mark is ruining the debate for me because he won't shut up. So I want to see if Mark can do that to me. Same thing with PhD Tony. I was watching the debate, and he just interrupts every 2 seconds. Every 2 seconds. That's why he's so mad at Witsit. Because even though he interrupted Witsit every 2 seconds.
Okay. Like I said, we don't want to do a big meta analysis. You can do this in your own space. That's totally fine. I didn't even want to entertain it. I saw it was the first super chat, and you were ready to just go. And but yeah, if we're just gonna do meta analysis, we just have to rail it in here, right? So Tim Pryor says, until he can name any field of science or scientist that agrees with him, then he needs to stop mentioning science.
That was to you, Ross.
Are you sure? Because I'm the only one that recording scientists today. You didn't. What are you talking about? I quoted scientists all day. Couldn't have been me. Couldn't be. He's talking to you. Last word, Tony. Go ahead.
Well, I quoted scientific papers. Ross presented out of context, presumably popular science media, that he failed to correctly interpret. So his claim that he represented what science was saying is wrong. He put quotes on the screen and then he made bizarre and insane interpolations from them to support his deranged hypothesis that the Earth is flat and stationary, despite all of the evidence that I presented that his model was wrong. Last word.
That's A1. We got the last super chat coming in. We'll do our closing statements. Positively Diverse Podcast comes in with another super chat. So thank you so much for the second super chat here. Let's see. Thank you, Tony. Ross, find a fan and experiment, please. Please, they say.
I did. Thank you. Thank you for that super chat.
All right, excellent. So let's move into 1 minute closings. Tony, 1 minute on the floor. Your thoughts on our discussion tonight, where everybody can find you, and maybe some other topics you'd like to discuss on modern day debate.
So I'd be very keen to discuss Witsit's theory of gravity, but he refuses to debate me because he's a coward. So that's a good place to start. the next thing that my observation about this discussion was that Ross made an unsubstantiated series of assertions. He started with the claim that Earth's shape is related to its motion. This is false. He claimed that Earth's position in the universe is related to its shape. That was false. He presented a bunch of completely out of context quotes from a variety of people that he had completely misinterpreted. And then he said that that was what science says, ignoring the fact that there is not a single scientist who will say that any of his interpretations are correct. They do not. Science does not claim that the electron doesn't exist. Science does not claim that the Earth is the center of the universe. Science does not claim that the sun goes around the Earth, and science does not claim that the Earth is stationary. Science claims none of these things,
10
and
seconds.
his repeated assertions were completely unsubstantiated in that regard.
All right. Well, thank you so much, PhD Tony, for coming out and having the discussion on modern day debate. We really appreciate it. We hope that everybody who has fingers or any heat activating devices in their body, hit the like button. That's right. Yeah, coming full circle. All right, it's over to you, Ross. 1 minute.
I want to say I appreciate Ryan and Pastor Tony. You guys have been great this evening. I love coming to the Church of Science Denial and dealing with the reverends here in the house of God. It's been nice being here in the house of God. Either way, you can find me at Real Offended. I'm going to do an after show right now. I might pop on to Matters Now, depending on, who's over there and what the discussion is like. But look, man, undefeated in this. Like I present the evidence. Nobody has any evidence of the contrary. When you say that my quotes are quote mine or out of context, that's not true unless you can present a quote of the person saying the opposite. When you say it's out of context, you have to show me how in context it means something different. If you don't say that, then you're just being dishonest. All right. But he's a pastor. How can I expect anything less? You know what I mean? It's the name of the game if you're a pastor, right? You preach to people, you get money, and then you do something completely different. All right. So, like I said at the beginning of the debate, if you have a model and the model doesn't work, throw the model out. In 1933, the model of gravity was thrown out. Everything that requires gravity after that is science denied. All right. So if you want to come to my channel and show me evidence of something else, then all right. But as far as I know, I've done this 8 times. Nobody's been able to present evidence. All right. Listen. Shout out Ryan. Shout out Martin. Unlike Ozian, I love modern day debates. It's a great platform. You guys host great debates on here. When you guys were doing the slew of religious debates, there were some really interesting debates in there. I swear to God. Every time I had a whole bunch of them saved, like when you guys had the Hindus debating the Indians. Very good stuff. Very good stuff. So
even though you are saying nice things, you are.
Hey, follow me at Real Offended. You know what I mean?
No worries. Well, thank you so much, Ross, for the shout out to the channel as well. I did want to let you know you were at time there, and I do want to let Tony and you also get some time to yourselves this evening. So if you haven't already, hit the like button if you enjoyed discussions that are open and free like this on Modern Day Debate. We do have some upcoming debates on Modern Day Debate, so if you haven't already, hit the notification bell for the Trump or Biden debate. That's Alex Stein versus Dr. J. F. Garapi. And then on Friday, I am, this isn't totally confirmed, but we're looking at getting ADHD projects versus Big Country on. So it's looking like that's going to happen. So just keep an eye out for that. But if you haven't hit the notification bell, we got 2 new speakers coming on Sunday, allegedly Ian versus the Right Corner. You're not going to want to miss that. That's going to be Does God Exist? It's going to be a very broad debate, and we're going to be able to touch on hopefully many different subjects regarding that subject. So definitely hit the notification bell. Once again, big thank you to Tony, Real Offended, everybody who put in their super chats, and our live chat for keeping everything friendly.
I was going to say, last thing to the chat. All you guys in the chat saying that I don't this, I don't that, I promise you won't come and show me any evidence of what you're saying, all right? I'm going live right now. Don't come make a fool of yourselves.
All right. Well, thank you so much. And we will see you next time on Modern Day Debate. Thanks again for everybody being here. We'll see you. Have a good night. Wasting time all of my life, living in a world of aggression, tyranny's mixed with self-oppression. What am I to do but tear away when I'm boiling at the top? Try to find a way to fight the fire, smart derived from the minds of liars, to call the shots as you bow your heads, and the march never stops. The stars could be free, but this insanity bends you right by the knee. Running in circles now for something that can't be found. On a breath as you hit the wall, the rain starts to fall. You can run away, sing a tune that's true. I'll be beside you. To decay from tears of blood, regrets of laughter. Turn around as your heart beat faster. Your hollow shape as the faith begins to drop. Shelter can find your thoughts of suicide. It's hanging down by the frail. Running in circles now for something that can't be found, and there's no time for today. The world would be untrue. I will rise against you. Insanity bends you right by the nail. Running in circles now for something that can't be found. Out of breath, smash the wall. The water consumed all. You prayed away that the world would be untrue as it rose against you. The Did you think it would always be for free? Now sit back, watch it burn me.